Good afternoon, everyone.
Hello, sir.
Yes,
Sir, I have sir now in the previous classes in the slide number 4A
this one.
in
Okay.
yesterday's classes. Yes, sir.
What happened?
The question is about the minimum number of two input NAND gate. We have
What
seen,
minimum number of two input NAND gates?
yes, sir.
Yes,
We
yes.
have found three two input in NAND gate. Then why should we bother about this three input uh, NAND gate? We have already found three input NAND gate now, sir.
I'm not understanding your words. Please elaborate your question.
Sir, the question is the minimum number of two
Minimum
input
number of
NAND.
two input NAND gates. Two input NAND gates. Question is that.
Yes, sir. And
Yes.
sir, we have seen three T input.
Here I have to use a three input NAND gate to complete the function. As it is SOP, we have implemented using NAND. We were using three input NAND gate.
Yes, sir.
So we need to NAND these three.
Yes, sir. Sir, previously we have found three T input NAND gate.
Kashyap.
Sir, previously we have found three two input NAND gate.
Where it is previously found?
In the first level.
Yeah, here we have three, and here three input NAND gate is required to complete the function.
But the question is about, sir, minimum number of two input NAND
That
gate.
is the reason we have constructed three input NAND gate using all the two input NAND gates. That's what we have done. See here, at this we have a three input NAND gate. The three input NAND gate is replaced with two input NAND gates only.
Yes, sir.
Here it is required three input NAND gate. Follow class correctly. Yes, sir.
Yes,
Here
sir.
it was three input NAND gate, but question is two input NAND gate. That is the reason that three input NAND gate functionality XYZ whole bar is implemented using two input NAND gates. Did I use any other gate other than two input NAND gates?
No, sir. But the question is about the minimum number of two input NAND gate.
Yes, minimum number of two input NAND gates.
Then sir, answer should be three.
Answer is 6. To complete
Uh,
the function AB plus CD plus EF, how can I complete with only 3? With 3, we are getting that AB bar, CD bar, EF bar.
yes, sir.
Right? I will clear
Okay,
all
sir,
this
got
doubts
it.
because yesterday it was not, actually I have discussed, right, doubts about NAND or clearly.
Yes, sir.
Then why didn't you ask it at that time?
What? Sir, I was absent, sir.
Good, you were absent.
Now got it, sir.
Then
Yes, sir.
you can ask questions at
Now,
the end, please. Please, right?
okay, sir. Sorry, sir. Now got it, sir.
Thank you.
Okay, sir. Got it.
Right. Thank you. Thank you. Everyone, please wait till the end for your doubts. Right. Right. We have discussed XOR and XNOR. We were about to discuss XOR and XNOR property due to some disturbance, power failure. I was not able to continue the class. Right. Sorry, I might have disappointed you instead of continuing the interruption. I waited almost 45-50 minutes, but power was not come. So finally I concluded. We'll continue tomorrow. Yesterday I said that. Okay. Some of you or most of you are messaging me about the class. You said that why can't you have a group? If possible, most of you may be forming a group and getting information from the manager as well as faculty also may be messaging you, right? So if possible, not compulsory, you may be having your own issues, right? Yes. Very good. Very good if you get answer. But I'm going to discuss today. Sahil, I'm fine. Surya Teja, I talked about that, but you are not listening to me, I think. I told you that the VCD, accessory, all that codes will be discussed in combinational circuits. I might have repeated 3 or 4 times the same statement. Right? I think everyone might be knowing this. I told this, right? Okay, fine. I'll let you know. Fine. Now, let us discuss properties of XOR and XNOR. Come to the class. So, come out of that other discussions, right? So, let me take a XOR gate with AB inputs. Output is what? A bar B plus AB bar. Instead of that, if I use X bar and Y, if AB are inputs, A bar B plus AB bar. But in place of AB, we are using X bar and Y. So in place of A, X bar, in place of B, Y. So A bar means X bar whole bar is X, B is Y. Plus what is A? X bar. B bar means Y bar. What is this? X XOR Y. The same XOR gate, again, if I use X bar and Y bar inputs, two complementary inputs. If AB are inputs, A bar B plus AB bar is the expression. So in place of AB, we have now X bar and Y bar. So A bar means X bar whole bar is X, B is what? Y bar. Plus A means X bar, B bar means Y bar whole bar is Y. This is now X XOR Y. Then what we are observing, if one input is inverted, XOR is becoming XNOR. If two inputs are inverted, again it is XOR only. Again it is XOR only. Similarly, two input XNOR gate with inputs X bar and Y, if I apply, if AB are inputs, A bar, B bar plus AB. In place of A and B, we are using X bar and Y. So A bar means X bar whole bar is X, B bar means Y bar. Plus A means X bar, B means Y. It is X XOR Y. And similarly, XNOR gate with inputs X bar and Y bar. Then what will be the output? If I use AB inputs A bar, B bar plus AB, then so in place of A and B, X bar, Y bar are inputs. So then A bar means X bar whole bar is X. B bar means Y bar whole bar is Y. Plus AB means X bar, Y bar. What is this? X XOR Y. X XOR Y. What is that here? In XOR gate also, if one input is inverted, it is becoming XOR. If two inputs are inverted, it is becoming XOR only. Then conclusions of this discussion is XOR gate with one inverted input or bubbled input is functionally again XOR. Sorry, it is a functionally XOR. Observe it. XOR gate with two bubbled inputs, two inverted inputs is again XOR. XOR gate with one bubbled input is equals to XOR. XOR gate with two bubbled inputs, it is again XOR. It is again XOR. This is summary of last discussion. If one input is inverted, it is giving XOR is becoming XOR, XOR is becoming XOR. If two inputs are inverted, XOR is remaining XOR only. XNOR is remaining XNOR only. Bubbled inputs are inverted inputs. Moving to next slide. A XOR B is equals to A bar B plus A B bar. Is equals to what we can write? A XOR B whole bar. Is equals to what we can write? A bar B bar plus AB whole bar. Now A XOR B is equals to A bar B bar plus AB is equals to what we can write? A XOR B whole bar is equals to A bar B plus AB bar whole bar. Next, A XOR B XOR C is equals to A bar B bar C plus A bar B C bar plus A B bar C bar plus ABC plus ABC. Right? A XOR B XOR C is equals to A bar B bar C bar plus A bar B C plus A B bar C plus A B C bar. This is a XOR, 3-input XOR, which we have discussed. So now, after understanding this, let me discuss one important property of this. A XOR B, again XORing with C, is equals to, observe correctly, everyone. A XOR B means A bar B plus A B bar. Again XORing with C. Let me say it is X. Then what is it? X XOR C. What can I write? X bar C plus X C bar. What is X bar? A bar B plus A B bar whole bar. That is X bar. And with C plus what is that X? A bar B plus A B bar and with C bar. Then what we get here? A bar B plus A B bar whole bar is nothing but A bar B bar plus A B and with C plus A bar B C bar plus A B bar C bar. Then what we get here? A bar B bar C plus A B C plus A bar B C bar plus A B bar C bar, which is equals to A XOR B XOR C. Check with the expression. You can understand. Right. Now, A XOR B XORing with C is equals to, what is A XOR B? A bar B bar plus AB and right XORing with C. XORing with C. If I say it is X XOR C, X bar C bar plus XC. What is X bar? A bar B bar plus AB whole bar. A bar B bar plus AB whole bar X bar and with C bar plus what is X? A bar B bar plus AB and with C. Observe correctly. So A bar B bar plus AB whole bar is nothing but A bar B plus AB bar and with C bar plus A bar B bar C plus ABC. Then A bar B C bar plus A B bar C bar plus A bar B bar C plus ABC. It is equal to A XOR B XOR C. It is not equals to A XOR B XOR C. Check it out. This is what someone was asking yesterday while defining XOR. When you are XORing AB and again XORing with C, I'm not getting expected table what we are writing. That's what someone was trying to ask. I told them, or I told him, wait, I'm going to give you clarity. So that's what I'm trying to give you clarity. What is it here? When you are implementing A XOR B, again XORing C is giving A XOR B XOR C. If you are implementing A XOR B, again XORing with C is not equals to A XOR B XOR C. What do you mean by this? Let us understand here. See, XOR followed by XOR again is giving multi-input XOR. XOR followed by again XOR is not giving multi-input XOR. Then what is that here is a summary. XOR followed by XOR is giving multi-input XOR. XOR followed by XOR is not functionally equals to 3-input XOR. This type of discussions already we had. What is that here? OR gate followed by OR gate is functionally equals to 3-input OR gate. AND gate followed by AND gate is functionally equals to 3-input AND gate. Right? NOR gate followed by NOR gate is not functionally equals to 3-input NOR gate. NAND gate followed by NAND gate is not functionally equals to 3-input NAND gate. Right? Whatever we had already about NOR, NAND, right? OR and similarly with respect to XOR and XOR also it is observed. What is it here? XOR followed by XOR is giving 3-input XOR. XOR followed by XOR is not giving 3-input XOR. Don't compare. Right? By doing this, if you are expecting this, it is not correct. If you are doing this and expecting this type of this function is not possible. Is not possible. Is not possible. Karthikeyan, Bhavana, Manikanta Kumar, please lower the hands. I will give you chance to discuss doubts, your queries at the end. If it is unknowingly, please check yourself. When you are raising hands, I may be focusing on your right to answer this. So if it is unknowingly, please check yourself. Fine. This is about XOR followed by XOR is 3-input XOR, but XOR followed by XOR is not 3-input XOR. That's what we have discussed here. Yes, yes. Unknowingly, it is argued only. Thank you. Sai Krishna. Some more properties, let us discuss. A XOR B, again XORing with A is equals to A XOR B, again XORing with A equals to. What is A XOR B? A bar B plus AB bar. Again, XORing with A. If I say it is X, then what we can write? X bar A plus X A bar. What is that X bar? A bar B plus A B bar whole bar, X bar, and with A. What is that X? A bar B plus A B bar and with A bar. Then A bar B plus A B bar whole bar is nothing but A bar B bar plus A B and with A plus A bar B and with A bar B, A B bar and with A bar 0. Then A bar B bar and with A it is 0. A B and with A is A B plus A bar B. In these two, if I take B common, A plus A bar and with B. What is the resultant? B. A plus A bar is 1. So and with B it is a B. So what is it here? A XOR B, again XORing with A. Similarly, if I use A XOR B, again XORing with B is equals to A. It is A. Now, A XOR B, again XORing with A is equals to, must be B. Why? These two must be equal. Why? This and this are functionally equal. This and this are functionally equal. Right? So, what can we say? This in these two, in place of C, it is used A. So when this is giving B, this also must be giving B because both are giving same functionality. Similarly, A XOR B, again XORing with B is equals to A because these two must be equal. Now, if you're understanding all these, moving to next slide. A XOR B, right? Again XORing with AB. Find this expression. A XOR B XORing with AB. Right. A simple way we can analyze this, sir. In A XOR B XOR C, in place of C, we can use A and B and proceed. That is one method. In place of C, it is A and B. A XOR B XOR C expression we know. In that, in place of C, we can use A and B. That is one method. You can simplify, you will get the final answer. Or I do in another way. Let us see what is that another way. A, B are primary inputs of this function. What is the third input? Derived input based on A and B. And let me say that F is a XOR of these three. A, B, A and B. Third input is A and B based on AB input AB. So AB can be 0, 0, 0, 1, 1, 0, 1, 1. AB is 0, 0, 0, 1, 1, 0, 1, 1. Depending on AB combination, what can be A and B? 0 and 0 is 0, 0 and 1, 0, 1 and 0, 0, 1 and 1 is 1. Correct? AB possibilities are 0, 0, 0, 1, 1, 0, 1, 1. Based on AB, the third input A and B will be 0, 0, 0, 1. What is XOR of these three? We know that three input XOR. 0, 0, 0. XOR is what? 0. 0, 1, 0. XOR is what? 1. One input is 1. 1, 0, 0. Again, one input is 1. XOR is 1. 1, 1, 1. Three inputs are 1, sir. XOR is 1. Now, if you are observing F is 1 for AB01, AB10, AB11, what can be the F? If you are observing with respect to AB, AB01, AB10, AB11 function is 1. Only for AB00 function is 0. Then what is the F? A plus B. It is A plus B. Any doubt in that? It is logical OR function of A and B. Because for AB00 output is 0, AB01, 1011 output is 1. It is A plus B. Otherwise, F can be written as A bar B plus AB bar plus AB canonical form. Because primary inputs of this function is only two variables. Primary variables of this function is only two variables A and B. Third input is derived input based on AB. Primary inputs are AB. With respect to AB, if you are writing 0, 0, 0, 1, 1, 0, 1, 1 AB combination, A and B 0, 0, 0, 1. And applying three input XOR function, then what is it output we are getting? 0, 1, 1, 1. How you are applying that? Applying three input XOR 0, 0, 0. 0 number of ones 0. 0, 1, 0. One input is 1. XOR is 1. 1, 0, 0. One input is 1. XOR is 1. 1, 1, 1. Three inputs are 1. XOR is 1. Now finally observing that for which combinations of AB, F is 1. AB01, AB10, AB11. So for AB 0001, 1011, right? In that AB01, AB10, AB11, only function is 1. That means is A plus B. Or writing this canonical form, you can simplify. Right? So there was a question in previous ESC objective. A XOR B XORing AB and with A XOR C XORing with AC is equal to, options are given, but you can say answer now. A XOR B XORing AB, A XOR C XORing AC. Then what can be the? Result? What is this? A plus B. What about this? A plus C. What is this finally? A plus BC. It is a plus BC. So answer was given A plus B, A plus BC. That was the correct answer. Where is, okay, okay. Yeah, AB values I'm writing depending on AB combination. So primary inputs are AB. AB can be 0, 0, 0, 1, 1, 0, 1, 1. What is that A and B? End of these two. 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. Someone was asking about that. Right. Moving to next slide. The question was given in previous ESC objective. A XOR B is equals to canonical form A bar B plus AB bar plus AB. Simplification easy. In these two, I can take B common. What we get? A bar plus A. In these two, I can take A common, B bar plus B. Then what we get here? A bar plus A is 1, B bar plus B is 1. So B plus A, which is A plus B. Can I use AB two times? Yes, you can use because it is Boolean algebra. X logical or X is X only. It is not 2X like linear algebra. AB can be used any number of times. AB plus AB is AB only. X plus X is X only. Right. Now, the expression here is A XOR B is A bar B plus AB bar. And also can be expressed as A plus B and A bar plus B bar. Am I right? A bar B plus AB bar, which is A XOR B. And also can be written as A plus B and A bar plus B bar. I hope everyone knows this SOP and PYs. This PYs expression, if I write A plus B and with AB whole bar. Let me say that A plus B and with AB whole bar, let me consider X. We get here it is AX plus BX. Let me implement this AX plus BX using NAND gates. Two level NAND. It is A and here it is X and here it is B. What is X? AB whole bar. What is X? X is AB whole bar. So let me write that also. It is A and B. What is it here? It is A, it is B. What is this here? It is X. So without using this, what we have implemented here? AX plus BX using two level NAND. But X we know that it is AB whole bar. I'm substituting that. Now it is A, it is also A. Let me short these two. Observe correctly. This is A, this is also A. So what we can do by shorting these two, let me make it A. This is B, this is also B. What we have here? A XOR B. If I want to get A XNOR B, let me take a inverse of this. Is A XNOR B. Right? A XNOR B. If I write what we get here, A bar B bar plus AB. And also what we have, A plus B bar and with A bar plus B. Right? So A bar B bar plus AB is equals to A plus B bar and A bar plus B. Now A bar B bar, let me say it is X plus AB. What is X plus AB? X plus A and with X plus B. Let us implement this X plus A and X plus B using NOR gates. It is A, it is X, it is B. What I'm doing here? Two level NOR because POS expression. But what is that X? What is that X? A bar B bar, which is equals to A plus B whole bar. What is that X? A bar B bar, which is A plus B whole bar. A plus B whole bar. Again, NOR gate. Now, this is A, this is also A. Now, let me short these two here. This here, these are A, these are B. A, here it is B. What we get here? It is A XOR B. If I want to get A XOR B, again using NOR gate as an inverter. Then again, A XOR B. A XOR B. What we have done here, XOR and XNOR implementations using NAND gates as well as NOR gates. XOR and XNOR implementation using two input NAND gates and two input NOR gates. Now, let us see some questions, right? Which of the following ABC input combination can give Z equals to 1 in the cycle? Shubham, क्या हुआ? This is XOR gate, this is XNOR gate, this is a XNOR gate. Okay. So how to analyze this question? Let us see. Very simple question. What we are expecting at Z is equals to 1. When do we get Z equals to 1? XNOR gate when we have even number of ones. What is the even number of ones possibility? Either all zeros or two ones. Simple thing is at this position or at this terminals, you need to have even number of ones. It can be all zeros or two ones. It can be all zeros or two ones. Let us see what is the possibility here. This is XOR, this is XNOR with AB inputs. One is XOR, one is XNOR. If here it is 0, it will be 1. If it is 1, it will be 0. What is it here? These two are complementary. AB can be 0, 0, 0, 1, 1, 0, 1, 1. Whatever it be that, here it is possible to get 0, 1 or 1, 0. That means from these two, one is 1, other one is 0. From these two, one is 1, other one is 0. That means all zeros possibility is not there. See correctly. Here, all zeros possibility is not there. Why? From these two compulsory, one is 1, other one is 0. Why? These two are complementary. and its inputs are A, B common. So A XOR B, A XOR B. If this is 0, it will be 1. If it is 1, it is 0. Compulsory from these two, one is 1, other one is 0. One is 1, other one is 0. That means all zeros possibility is not there. The next possibility is 2 ones. To get 2 ones, C must be 1, no alternative. C must be 1, no alternative. Which option is correct? Directly D. C is 1 in only option D. I don't need to substitute option A, option B, option C, option D. Logically, if you are proceeding, Z equals to 1. XNOR gate inputs must be even number of ones. For that, all zeros are 2 ones. All zeros is not possible because one input is XOR gate output, other input is XNOR gate output. Compulsory, these two are complementary means either 0, 1 or 1, 0 means from these two compulsory one is 1, other one is 0. That means all zeros is not possible means next possibility is 2 ones. To get 2 ones, C must be 1. To get 2 ones, C must be 1. Or you can substitute. And the thing is, in this, if you're observing, AB can be 0, 0, 0, 1, 1, 0, 1, 1. Whatever it be that AB. If C is 1, Z is 1. Verify that also. AB can be 0, 0, 0, 1, 1, 0, 1, 1. Whatever it be that AB. If C is 1, then only Z is 1. If C is 1, then only Z is 1. So the possibilities are 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1. For all these 4 combinations of ABC, Z becomes 1. Not only for 0, 0, 1. From the given option, 0, 0, 1 is correct. It is not only for 0, 0, 1. It is possible to get other combinations also for which Z will be 1. Which are those? 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1. What is it? A equal to 0, B equal to 0 is not possible. I did not say that A, B, 0, 0. Here outputs of this XOR and XNOR 0, 0 is not possible. See where I'm talking. Look at the screen. Here 0, 0 is not possible on these two. What are these? Are they AB? No. XOR gate output and XNOR gate output. AB can be 0, 0, 0, 1, 1, 0, 1, 1. But whatever you apply AB, here it will be 0, 1 or 1, 0. That means here in these two, compulsory one is 1, other one is 0. Where XNOR gate inputs, those are not AB. Observe correctly. Follow correctly. What is it here? Here, AB can be any values. But what is the possibility of XOR gate and XNOR gate outputs? 0, 1 or 1, 0. That means if one is 1, other one is 0. That means on these two, 0, 0 is not possible. Right? So, one input is compulsory 1 from these two. Inputs of XNOR gate. Inputs of XNOR gate are not AB. Don't go with your assumptions. Look at the circuit correctly. I'm explaining. So I'm not applying AB here. I'm applying XOR gate output and XNOR gate output as inputs of XNOR gate. Then, so AB, any values, but these two are complementary outputs. If one is 0, other one is 1. If one is 1, other one is 0. Means from these two, either 0, 1 or 1, 0 possibility is there. That means 0, 0 is not possible here, not on AB. I did not say that AB 0, 0 is not possible. Right? So here it can be 0, 1 or 1, 0. That means here one input is 1, other input is 0. Which one is that doesn't matter for XNOR gate. Now, to get two ones here, C must be 1. No alternative. If C is 1, then Z is 1. Otherwise, it will be 0. What will be AB? Can be any value, doesn't matter. AB can be 0, 0, 0, 1, 1, 0, 1, 1. Nagalingeshwara, who said that? Did I say? A XOR B whole bar is A XNOR B. A XNOR B whole bar is A XOR B and with C bar. Here A XOR B whole bar is A XNOR B and again A XNOR B plus A XOR B. A XNOR B whole bar is A XOR B and C plus A XOR B, A XNOR B. These two are complements means X and X bar will be 0. And here also X and X bar 0, 0. A XOR B and with C plus A XOR B. And here A XOR B and with C plus 0. What we get here? C common. A XOR B plus A XOR B and with C. A XOR B plus A XOR B, or we can write expression also. A bar B bar plus AB plus A bar B plus AB bar. Or when one is X, other one is X bar. X plus X bar is what? 1. And with C. 1 and C is C. Some people are worrying about what can be the Boolean expression. It is C. If C is 1, output is 1. If C is 0, output is 0. What is AB? It can be any value. Is output expression is depending on AB? No. This is 1 because if it is x, it is x bar. X plus x bar is what? 1. X and x bar is what? 0. Because here A XOR B, it is A XOR B. A XOR B and with A XOR B whole bar. X and x bar is what? 0. 0 and C. Here also, if you are observing, A XOR B whole bar is A XOR B. A XOR B whole bar is A XOR B. Again, here it is what? X and x bar. X and x bar is 0. Which was given in previous exam. This is a circuit. Let us analyze this circuit. What do we have here? XOR gate. What is the inputs? X and Y. What is the output? X XOR Y. Right? Now XOR gate, X XOR Y, XORing with X. X XOR Y, XORing with X. What will be output? Y. Any doubt in that? It is Y. A XOR B, again XORing with A is equals to B. So X XOR Y, again XORing with X is equals to Y. What is the inputs of this XOR gate? X and Y. Output is X XOR Y. X XOR Y. Coming to this XOR gate, one input is X, other input is Y. What is the output? X XOR Y. XOR gate, X XOR Y is one input, other input is what? Y. So X XOR Y, XORing with Y is X. This XOR gate, one input is X, other input is what? Is also X. One input is X, other input is also X. X and X XOR, if you are applying, what is that here? 0. Now, for this XOR gate, one input is 0. What will be the output? XOR gate, if one input is 0, output is A. XOR gate, one input is 1, output is A bar. I hope everyone knows this, sir. I discussed this, sir, while analyzing about enable and disable. So one input is 0, output is other input. One input is 1, output is complement of other input. XOR gate, one input is 0, output is what? Other input. Answer is C. Some of you are saying 0, that I can understand why you are saying 0. By assuming that this network and this network are resulting same, when these two are same, output is 0. Am I right? They are not same. They are not same. If they are same, for example, here also X XOR Y is there, would have been output is 0. Right? Some of you have replied answer is 0, which is wrong. Check it. Now, F1 F1 of A comma B comma C is equals to sigma M of 2, 3, 7. F2 of A comma B comma C is equals to sigma M of 3 and 6. F1 is function of ABC and it is equal to sigma M of 2, 3, 7. F2 is function of ABC, sigma M of 3 and 6. Now, if I take R of these two, what is it here? F1 and F2. If I say F is a function, F of A comma B comma C, what will be the resultant? What we are doing here? F1 is a function, F2 is a function of ABC. Then I'm taking logical OR of these two functions. What will be the resultant? To write this, let me write the expression of F1. What is here? 2 is minterm is 0, 1, 0 is indicating A bar B C bar is minterm. So 3 is minterm is 0, 1, 1, which is A bar B C. And 7 is minterm. So ABC 1, 1, 1. So it is ABC. Right? F2 of A comma B comma C equals to sigma M of 3 and 6. Then what is it here? 3, 0, 1, 1, which is A bar B C. 6, A B C bar. Right? Just a minute. Yes. Then what should I write here? F of A comma B comma C is equals to F1 logical OR with F2. Then what I can write? A bar B C bar plus A bar B C plus A B C plus A bar B C again plus A B C bar. Then if you are observing A bar B C plus A bar B C is resultant to A bar B C. Then A bar B C bar plus A bar B C plus A B C bar plus A B C is equals to sigma m of 2, 3, 6, 7. What is that we have done? Union of minterms. When you're taking logical OR of two functions of same variable, then resultant is what? Union of minterms. So 2, 3, 7, 3, 3, 6. So union is 2, 3, 6, 7. 2, 3, 6, 7. Then logical and if I do logical and of F1 and F2. So let me take another function resultant. Let me say g of a comma b comma c equals to F1 logical and with F2. Then let me do AND of these two. What is it here? A bar b c bar plus a bar b c plus a b c and with what is it here? A bar b c plus a b c bar. Then what you get resultant? A bar B C bar and with A bar B C. C and C bar it is 0. A bar B C and with A bar B C. It is A bar B C. A B C and with A bar B C. A and A bar is 0. A B C bar is and with this. So A bar B C bar and with A B C bar. A bar and A is 0. Plus A bar B C and with A B C bar. Again A bar and A is 0. A B C and with A B C bar. C and C bar is 0. So resultant is what? A bar BC is equals to sigma m of 3. Then what is it here? When you're ANDing these two functions, resultant is a intersection. Resultant is intersection. When you're taking R of two functions, resultant is union of minterms. When you're taking AND of two functions, resultant is a intersection. Resultant is intersection. Once again, when you're taking R of two functions, it is union of minterms. When you're taking AND of two functions of same variable, resultant will be intersection of minterms. What is intersection? Common minterms. So we have 3 as a common for these two. That is a resultant. Take inverse of a function. Let me say F2. And what is that F2 bar? Let me read what is F2 bar. A bar BC plus ABC bar whole bar. Then A bar BC whole bar and with ABC bar whole bar. Then A bar BC whole bar means A plus B bar plus C bar and with A bar plus B bar plus C. Right? A plus B bar plus C bar and with A bar plus B bar plus C. What is it here? A plus B bar plus C bar is maximum of new function F bar. So maximum expression is what? A plus B bar plus C bar. What is that here? A means 0, B bar means 1, C bar means 1. So 0, 1, 1 is maximum. That is 3 is maximum. Next, A bar plus B bar plus C is maximum. What is that here? 1, 1, 0. It is what? 6. So it is equals to pi m of 0, 1, 1, 3, 1, 1, 0 is 6. What is exactly F2? Sigma m of 3 and 6. What about F bar? Pi m of 3 and 6. Point should be observed, understood correctly. Don't deviate from the discussion, sir. If you need, I'll wait for 2 minutes to relax. But you have to focus on each and every discussion, because every topic is important for competitive exams. If you're getting a question, that one question may be sufficient to change our life. Right? Sigma m of 3 and 6 is f. What about f bar? Pi m of 3 and 6. So what can I write? F sigma m of 3 and 6 means it is equals to pi m of 0, 1, 2, 4, 5, 7. Right? So sigma m of 3 and 6 is equals to pi m of 0, 1, 2, 4, 5, 7. These two, sigma m of 3 and 6, pi m of 0, 1, 2, 4, 5, 7 are representing, these two are representing f, representing same function. It is SOP, it is POS of f. Point should be understood correctly. This is SOP, this is POS of f. And coming to f bar, pi m of 3 and 6 is equals to sigma m of 0, 1, 2, 4, 5, 7. Then pi m of 3 and 6 is equals to sigma m of 0, 1, 2, 4, 5, 7. F bar is represented with pi m of 3 and 6 and also equal to sigma m of 0, 1, 2, 4, 5, 7. Understand correctly. So pi m of 3 and 6 is f bar. Pi m of 3 and 6 is POS of f bar is equals to sigma m of 0, 1, 2, 4, 5, 7 is SOP of f bar. See, these two are representing f. These two are same. One is SOP, one is POS, which are representing f. And this is POS, this is SOP. These two are representing f bar. These two are same representing f. These two are same representing f bar. But these two are not same. These two are not same. Try to understand correctly. The same f can be represented with sigma m of 3 and 6 or pi m of 0, 1, 2, 4, 5, 7. Coming to f bar can be represented with pi m of 3 and 6. The same can be represented with sigma m of 0, 1, 2, 4, 5, 7. Right? When you're taking complement of a function, in f, min terms are becoming max terms of f bar. Max terms of f are becoming min terms of f bar. Point should be understood correctly. When you're taking complement of a function, min terms of f are becoming max terms of f bar. Max terms of f are becoming min terms of f bar. Min terms of f becoming max terms of f bar. Max terms of f becoming min terms of f bar. Already we have discussed SOP POS. Sigma m of some numbers, pi m of remaining numbers. And also we mentioned that these two are representing same functionality. Correct? So when you are representing f2 with sigma m of 3 and 6, same f2 can be represented with pi m of 0, 1, 2, 4, 5, 7. That is, one is SOP, other one is POS. SOP, POS are functionally same, functionally equal. If you are missing the classes, I cannot help you. If you are attending classes regularly, observe what we have discussed about sigma, some numbers, pi of some numbers, pi m of some numbers, then we have confirmed sigma m of numbers which are min terms is equals to pi m of remaining numbers which are max terms. All these two are representing same functionality. According to our discussions earlier, Boolean algebra basics, here f is sigma m of 3 and 6. The same sigma m of 3 and 6 can be represented with pi m of 0, 1, 2, 4, 5, 7. These two are representing only one function, which is f. If you are observing complementary function, what is happening here? Here it is pi m of 3 and 6. These two are max terms of f bar. Means which are those? A plus b bar plus c bar is max term. That means 0, 1, 1 is max term, which is 3. Right? Coming to a bar plus b bar plus c is nothing but 1, 1, 0 is max term. That is 6 is max term. So 3 and 6 are max terms of f bar is equal to sigma m of 0, 1, 2, 4, 5, 7 are min terms. Right. 2 minutes. Give me 2 minutes. Prasad Rao. Then f is equals to f bar. When you are saying that min terms of 3 and 6 is equals to max terms of 3 and 6 means you are confirming that f equals to f bar. Is that? Did I say that? No, I did not say that. If you are assuming I'm not responsible, see, what I mentioned is if you are checking correctly, these two are equal. What is it here? Sigma m of 3 and 6 is equals to pi m of 0, 1, 2, 4, 5, 7. These two are equal. And these two are equal. I did not say this is equal to this. I did not say that. Did I say that? No. What we mentioned? Sigma m of 3 and 6 is equals to pi m of 0, 1, 2, 4, 5, 7. These two are equal. And these two are equal, which are representing f bar. These two are equal, representing f. These two are equal, representing f bar. Don't go with your assumptions, sir. Prasad Rao. Done? Naveen, later. Right. What happened? Nagalingeshwar Rao. Yes, that is correct. Where are you getting doubt? A plus BC whole bar. Oh, you did not write bar? It is wrong. How can it be correct? What you have written right side is a complement of A plus BC, right? How can they both equal? It cannot be. Nagalingeshwar Rao. Okay, okay, Prasad. No issues. No, it will not be given. There may be bar, it may be missing that. Right. After all these discussions, right, the logic gate basics, Boolean algebra basics, let us see one more thing. I will discuss. Nagalingeshwar Rao, I will discuss. Hold on. Next is when Venn diagrams are given, we need to find Boolean expression. This type of questions also we have been getting. Let us see those type of questions. When Venn diagrams is given, I hope everyone is familiar with Venn diagrams, sir. So when Venn diagrams is given for a specific region in that Venn diagram, we need to write Boolean expression. Let us see how to write. Simply, if I consider Venn diagram like this, if I say these two are A and B, what is the Boolean expression of shaded region? What is the Boolean expression of shaded region? With respect to set theory, what we can say? A intersection B. What do you mean by intersection and function? right? So what is it here? If you are observing with respect to set theory, what is it here? It is A intersection B. It is a intersection B. If it is intersection means with respect to Boolean algebra and function. So what we can say, it is a and B. Check it correctly. The region which is covered by A, which is also covered by B. That means A intersection B, which is A and B. A and B. Check it correctly. How to write a Boolean expression for specific region specified. So in this AB, if I use variables here, the common region is A intersection B, which is A and B, which is A and B. A, B. What is the Boolean expression of shaded region? What is Boolean expression of shaded region? What is it here? If you say the region which is shaded, the region which is covered by A, which is not covered by B. What is here? The region should be covered by A, the entire region of A which is not covered by B. The entire region of A which is not covered by B. What is that here? A should be covered, B should not be covered. A intersection B bar, which is a B bar, which is a B bar. The region which is covered by A, which should not be covered by B. That is A intersection B bar, which is a B bar, which is A B bar. Boolean expression of shaded region. If I say A and B. Yes. Yes. Some of you are writing correctly. Very good. See, this region, also this region. This region expression already we know that A, B bar. Also this means it is union, means plus. This region, also this region. This region include this region. That means this region is A, B bar. Also this means union. Union means plus, logical OR. What is this region? The region which is covered by B, which is not covered by A. That means it is a bar B. So this region, also this region plus this region. This region is what? A B bar. Union plus also this region is A bar B. A bar B. The Boolean expression for shaded region. Ashish Kumar, if you are saying AB complements means you might have observed set theory or Venn diagrams, all function, that is mu, right? You are saying that AB bar means AB is not covered. AB is not covered. Everything is covered in universe. If you remember the set theory or Venn diagrams correctly, you might have studied that there is a mu function, entire universe. Ashish Kumar, very good. What is sample space? Right. See, what about this region? The region which is covered by A, which is not covered by B, which is not covered by C. Be clear about this. The region which is covered by A, which is not covered by B, which is not covered by C. Then A, B bar, C bar. Or what is this region? The region common for B and C, which is not covered by A. The region common for B and C, that is intersection of B and C, which is not covered by A. So it is a bar B C. Be clear about that. See, this is region which is covered by B and C, which is not covered by A. That is a bar B C. This region, the region which is covered by A, which is not covered by B, which is not covered by C. So it is A B bar C bar. Anyone is having any doubt? Next. Boolean expression of shaded region. Right. Very good. Good response, sir. Monica. What happened? We'll discuss at the end. Right. So, how many parts we have? You may analyze this in 3 parts, or we can analyze in 2 parts also. First, let me complete with 3 parts. Let me complete with 3 parts. So, here what we have, this region is A, B bar, C bar plus. And what about the second region? A, B bar, C. Am I right? A, B bar, C. What about third region? This is the region. What we get this, sir? A bar, B, C bar. Any doubt in that? First region is A, B bar, C bar, because region covered by A, which is not covered by B as well as C. And second region, if you are observing red one, what is it here? It is common for A and C, which is not covered by B. Then A, B bar, C. And what about third region, the green one, which is A bar, B, C bar. But if you are observing in these two, A, B bar common, C bar plus C plus A bar, B, C bar. So C bar plus C is 1. Resultant is what? A, B bar plus A bar, B, C bar. This directly we can analyze. How? Let us see. This considering as one part, the region, entire region of A, which is not covered by B. See, with blue, I am mentioning that the region which is covered by A, which is not covered by B. Entire A region, which is not covered by B, means it is a B bar. This part is covered. Remaining is only this one. What is that here? This region is A bar, B, C bar. A bar, B, C bar. Because the region covered by B, which is not covered by A, which is not covered by C. Yes, A bar, B, C bar. Right? Simple question. You can analyze this into 3 parts, or you can analyze with 2 parts also. If you are analyzing with 3 parts, you are getting simplification. You need to do simplification also. Boolean expression of shaded region. Right. Most of you are answering correctly. Let me do that. So how can we analyze this entire C is there, right? One part. It is C. And what is remaining? This is what is remaining, right? Right. One part is entire C. Second part is what? AB, which is not covered by C. So AB, C bar. Right. Now, this can be simplified. What is it here? Using distributive law, C plus AB and with C plus C bar. Distributive law. A plus BC equals to A plus B and A plus C. Now here C plus AB C bar. C plus AB and with C plus C bar. C plus C bar is 1. Resultant is what? C plus C plus AB. If anyone is having any doubt, you can message me in the Q&A. C plus AB. Simple. Entire C region. And what is remaining here? C bar AB. That's what I have written. And applying distributive law, we are expanding this. Simplification is possible. A, B, C. Boolean expression of shaded region. So here we are in Boolean algebra. Whichever is possible to minimize further, we go with that. That you will understand more later about minimization. Sai Pratyush. Wait. Yes, the ABC region is covering twice. Still, complexity of Boolean expression is reducing. That is the reason we go with C plus AB. Monica, wait. If you have any doubt, you can message me in chat box. Very good. Hema, very good. Toye Jakshudu, very good. Gopal Krishna, to check it once. So what can we write here? One is we can analyze this into 4 parts. Then finally simplification is possible. So first, if I analyze this part, what we get here? A, B bar, C. If I analyze this part, what we get here? A bar, B, C. If I analyze this part, what is it? A, B, C bar. If I am analyzing the center one, which is A, B, C. But simplification is possible. In these two, if I take AC common, B bar plus B. If I take BC common in this, what we get here? A bar plus A. If I take AB common in this, what we get here? C bar plus C. Then AC plus BC plus AB. Right? So AB plus BC plus AC is the expression. Boolean expression of shaded region. Yes. Right. If you are analyzing, this part is what? A, B bar, C bar. And what about this part? A, B, C bar. Plus, what we have here? The region which is covered by B, which is not covered by A and C. So, A bar, B, C bar. Now, in these two, A, C bar common, B bar plus B. And in these two, B, C bar common, then what we get? A plus A bar. Finally, A, C bar plus B, C bar. Because A plus A bar is 1, B bar plus B is 1. So, A, C bar plus B, C bar. A, C bar plus B, C bar. A, B, C bar is indicating only this region. Region covered by A and B, which is not covered by C, it is A, B, C bar. Only this much it is covering. Someone is asking why can't we write it A, B, C bar? As I'm writing A, B, C bar, which is covering this part only, but I need to cover this entire region. I'm using Boolean axioms, if possible, to simplify. Ganesh. Yes. Yogesh, I'll discuss at the end. If you want to interact with me, that I'll give you a chance at the end. What? One more time, Naveen? What you want me to explain once again? Which one? No, I'm not giving any chance to anyone. Monica, if you have any doubt, you can message me in chat box. Right. Let me take a small break. After break, we resume and we'll continue. Let me take 15 minutes break from now. See you in 15 minutes. Right, welcome back. Right, these are Venn diagrams we have discussed. Now, let us go with one more important topic in logic gates, which we are introducing. And in coming topics also, we are going to extend about this. The concept is please wait if you have any doubt with respect to specific Venn diagram. I'll talk in the doubt session, right? Some people are asking about some specific Venn diagrams. Fifth example means fifth slide or fifth example, fifth Venn diagram. Surya Teja, fifth Venn diagram. Jashwanta, why are you saying that ABC will come in this one? Where is that ABC? ABC is not included. Why are you saying ABC? And Surya Teja, you are asking about fifth example means is this one? You want me to explain this one? Fifth example means, am I right? No. Then which one? Fasting to fifth. What is it? Fasting to fifth. What Surya Teja is asking, I'm not able to understand. 1, 2, 3, 4, 5. This is fifth example. Otherwise, say slide number, frame number. No. Tasnik. No. Check it. Okay, Surya Teja. Okay. So you want me to explain this one, right? See, simply observing this is what is it here? A B bar. The second part is what? A bar B C bar. That is one way. Second way is analyzing as three parts. One is this part is what? Follow correctly. I'm writing this part. I hope you are following. This part is A B bar C bar. And what about this part? A B bar C. Correct. The region which is covered by A and C, which is not covered by B. A B bar C plus. What about this region? No doubt. A bar B C bar. In these two, A B bar common. Then C bar plus C plus A bar B C bar. Then C bar plus C is 1. A B bar plus A bar B C bar. What was your doubt? If possible, try to type, right? Surya Teja. Nagasai Manikanta. We'll discuss. Right? Okay. If I keep on discussing here, I'll be here only. So We'll discuss in the doubt session. If you have any doubts with respect to any slide, I'm going to talk. Right now, propagation delay. Propagation delay. What is this propagation delay? Why we are getting propagation delay? What is the effects of propagation delay? All these we need to understand. Let us see one by one. So, what is propagation delay? Delay in propagation. What is propagation delay? Delay in propagation, correct? But what it is propagating from where to where? From where to where? Inputs to output. Be clear about that. Inputs to output, it is propagating. What it is propagating from inputs to output? Changes. Don't say signals, sir. Generally, you might be saying that what it is propagating means signals is propagating. No, actually, with respect to our analysis, propagation delay, what we need to check is there are changes in the input. The changes will not occur in the output immediately. The changes will occur after some delay from the point inputs changed. See, delay in propagating changes from inputs to output is called propagation delay. Once again, propagation delay is nothing but delay in propagating changes from inputs to output is called propagation delay. It is general definition which may not be giving clarity while analyzing propagation delay with circuits. But what else we need to understand about propagation delay is if there is a change in the output, focus on my words, sir. If there is a change in output due to changes in inputs, the change is occurring in output after propagation delay time from the point inputs change. Let me repeat once again. If there is a change in output due to changes in inputs, the change is occurring in output after propagation delay time from the point inputs change. Let us see what is exactly we are talking. So let me write definitions first, then we'll understand meaning of each and every word. Right? So propagation delay is nothing but the first definition, general definition, delay in propagating changes from inputs to output is called propagation delay. Or second definition, if there is a change in output due to changes in inputs, the change is occurring in output after propagation delay time from the point inputs changed. From the point, inputs changed. See, got an announcement or a schedule announcement. Tomorrow, as usual, you have a 2 to 6 schedule, and Sunday you are getting holiday. Tomorrow, Saturday, you have class 2 p.m. to 6 p.m. And the day after tomorrow, that is Sunday, is holiday for you. Happy? Chakravarti, when it is said Sunday is holiday means Monday again classes will be there, right? Sahil, it may be adjusted, it may be changed. Okay, let us come out of that happiness about Sunday. So let us focus on this. Yeah, we'll let you know by tomorrow. Anyway, tomorrow we have class. It will not be like that, Ananda. That depends on right situations, right? Not compulsory. Every Sunday it will be all day. Karthik, I don't know all those. It will be informed, right? By tomorrow, you will get all such information. Kashyap, that we cannot say. If you are interested to come out now, we are not interested to come out. You may be interested in offline, but in this situation, we cannot come out. Don't expect immediately offline. That depends on situations and conditions. Okay, that I do, Ashutosh. Wait. Yeah, classroom practice questions are homework questions only. I will frame some more questions. I'll be posting that. Wait for such questions. Right, my questions. I'll be framing some questions. I'll give you such questions. Wait, homework problems. All the classroom practice questions, previous GATE and ESC questions are homework only. From every topic you have to solve. Right. Okay, let us come back to the concept which we are discussing. Propagation delay. What is it here? Delay in propagation. Delay in propagation. What is it here? Delay in propagating changes from inputs to output is called propagation delay. But particular definition which is helping us in analyzing logic circuits is if there is a change in output due to changes in inputs, the change is occurring in output after propagation delay time from the point inputs changed. If there is a change in output due to changes in inputs, the change is occurring in output after propagation delay time from the point inputs changed. From the point inputs changed. Right? Now, let us try to understand this definition. Please Read yourself the second definition. Now, let me take an OR gate with A and B are inputs, output is Y, and propagation delay of this OR gate is delta. The inputs A and B with respect to time are changing like this. Proceed to draw that output waveform including propagation delay. We'll be back in 2 minutes. Right. Sorry. Welcome back. Yes, sir. These are inputs A and B variations with respect to time. X-axis is time axis, Y-axis is voltage, logic 0 and logic 1. Try to understand point correctly. X-axis is time axis. With respect to time, A and B variations are specified. Now, we need to draw output waveform Y, including propagation delay. Including propagation delay. Once again, we need to draw that output waveform, including propagation delay. Let me draw that Y. What I'm drawing now? Y. So for AB00, what will be R gate output? 0. You don't need to worry where A is changing from 1 to 0 or B changing from 1 to 0. So initial conditions, stable input, stable output. No need to worry about that where it was changing from 1 to 0 and all. Assume that from infinite time it was 0. Then for stable, initially stable input, stable output 0. Right? Right. At this point of time, A is changing from 0 to 1. At this point of time, A is changing from 0 to 1. Because of this, 1, 0, R gate output is 1. Because of this 1, 0, R gate output is becoming 1. That 1 we see after propagation delay time. After propagation delay time. See, yes, output has to become 1. But output cannot become instantaneously. There is a delay to get output from the point inputs changed. Yes, inputs are changing. Yes, output is changing after propagation delay. And again here, B is becoming 1. For 1, 1, what is R gate output? Again 1. So for A is 1, B is 1. For 1, 1, R gate output is 1. That 1 we see after propagation delay time. After propagation delay time. What is here? Here B is becoming 1. For 1, 1, R gate output is becoming 1. That 1 we see after propagation delay time. After propagation delay time. Is not required. It is not required. Understand correctly? It is not required. Why? Read definition correctly. Second definition, if there is a change in output due to changes in inputs, the change is occurring after. See, the change is occurring in output after propagation delay time from the point inputs changed. Yes, if there is a change in the output, then only we need to include propagation delay. Wherever there is a change in the input, there we don't need to consider propagation delay. I hope you are following. Wherever there is a change in the input, there we don't need to consider propagation delay. Because of these changes in the input, if there is a change in output, there we need to consider propagation delay. Here, input is changing, output is also changing, propagation delay is considered. Here, input is changing. For 1, 0, OR gate output is 1. For 1, 1 also OR gate output is 1. There is no change in the output. There, we don't need to consider propagation delay. Once again, A is changing from 1 to 0. For 0, 1, OR gate output is 1 only. There is no change in the output. Even though input is changing, output is not changing. No need to consider propagation delay. Once again, A is 0, B is changing from 1 to 0. Then output has to change from 1 to 0. That 1 to 0 will occur after propagation delay time. So here it is a delta. So this is what we need to analyze. So to draw these waveforms, general definition will not help us. So if you are analyzing, if you are applying second definition, it will be helpful, right? If there is a change in the output due to changes in the input, the change is occurring in output after propagation delay time from the point inputs changed. Understand correctly, you will enjoy this in combination as well as sequential also. Right? Right. So first of all, why are we getting propagation delay? Why are we getting propagation delay? transient response. What is the reason for transient response, sir? Capacitance. What is the reason for capacitance, sir? Parasitics of devices. Device is offering resistance and capacitance. Now, so wire parasitics. Wire is also offering some resistance and capacitance. Because of all these, there will be output node capacitance. That output node capacitance is charging or discharging for changes in the outputs. Whenever there is a change in the inputs, for these changes in the input, there is a change in output. The changing logic 0 to logic 1 is nothing but two different voltages. If it is 0 volts to 5 volts, it is charging output node capacitance is charging from 0 volts to 5 volts. Or if output is changing from 1 to 0, again it is discharging from 5 volts to 0 volts. These chargings and dischargings cannot be instantaneous because of capacitance. Capacitance is not allowing sudden voltage changes. Right? Capacitance is not allowing sudden voltage changes, means it is taking some time to charge to the expected. It is taking some time to discharge to the expected. So finally, what is that here? It is taking time to change the output. The time required is called propagation. Once again, reason for propagation delay is a transient response. Reason for transient response, capacitance. Capacitance, reason for capacitance, parasitics of devices, parasitics of materials or metals we are using. So finally, what is happening here? So the output changes are not occurring immediately. Because of this propagation delay only, we have been getting more jobs as electronic engineer. If you don't have propagation delay, what you are going to optimize? Because when we are using 2 gigahertz mobile, 2 gigahertz speed mobile, we are looking for 2.5 or 3 gigahertz mobile. That means you need to improve the frequency of operation. That is possible by reducing propagation delays of device and logic gates. For that, we are being getting paid as electronic engineer. Right? So, electronic engineer is getting paid just because of capacitor only. We need to thank capacitor. If you don't have capacitor, there is no work for you as electronic engineer. So we need to thank the capacitor. Don't worry about capacitor. When you are seeing the capacitor in networks, people might be worrying, oh, capacitor, right? Otherwise, what is that? Applying theorems and all. But when we are observing that capacitor or inductor, then we are worrying about analysis. But that capacitors and inductors only are helping us to sustain as electronic engineer. Be thankful to electronic inductor and capacitors. Even though, yes, Arun Revant, what is that? Why are you playing in the chat box? Om Shri Krishna Karanam. So in analog circuit, you might have observed what is the capacitance at each and every terminal. Capacitor, right? So we are not seeing in logic gates. Every standard cell vendor will be providing all such delays. So delays are provided with respect to input transition time and output load capacitance. We are going to use that lookup tables in calculating propagation delay of each and every logic gate. V means tool is capable of doing that. So we are trying to reduce that propagation delay by reducing the capacitance. For reducing the capacitance, we have been reducing the transistor size. Right? Arun Revant, which signal is that? Right? Is it audible now? Mangesh, from my side, I've been sending immediately once the class is completed. I am doing my duty from my side. If there is any issue, it is not with me. On the same day, after completion of class, have been sending all the slides. That's my duty. I'm doing that. Right? If there is any delay, it is not from my end. What is PD repeat? Pratik Pramod. Every time wherever there is a change in the output, there we have propagation delay. Pratik Pramod, what is your question? Propagation delay repeat means what is that? Once we are getting propagation delay here, once again output is changing. Wherever there is a change in the output due to changes in the input, everywhere we need to consider propagation, not only once. It may be changing from 0 to 1. So after that, after some time, your inputs of logic gate may be changing. Then what happens here? Again, output is changing from 1 to 0. So whether it is changing from 0 to 1 or 1 to 0, for every change in the output, where there we need to consider propagation delay. Yes. So reason we have understood, and also some of you are thanking capacitor already, right? Right. Okay. No one will thank me. You are thanking capacitor because you are going to get job because of capacitor, right? Not because of me. Okay. Yes, yes. Right. Pratik Pramoda, according to you, transients means once it is settled, it won't be repeating because the circuits you are considering your switch is only once you are moving. Are you moving multiple times? If you keep on changing that switch, one position to another position, obviously you'll be observing transient again and again, repeating. Pratik Pramod, in the network circuits you have analyzed, there we are providing that one switch is moving from 1 to 2 or one switch is moving from 0 to 1. That's it. That is the reason you are assuming that transient will be only once. No, no. Your switch is changing again and again. 0 and 1, 0 and 1. Then what happens? There will be transient multiple times. Pratik Pramod. Why propagation delay is repeating if you are getting a doubt, right? So universe circuits which you are analyzing, there you have only one switch is moved. But in our circuits, in our logic circuit, our switch will be moving multiple times. Right? Okay. Right. So this is one way of analyzing output waveform while including propagation delay. I hope you are clear with this. I'm going to use another way of analyzing same with a simple analysis. Let us see what is that. Bhaskar. Many are asking very different questions. Okay. As I introduced as electronic engineer, you must know all this information. Okay. Param do they? Why don't you have capacitance in logic gates? Logic gates are constructed using devices, right? Devices. It may be bipolar or unipolar devices, right? So when you are using devices and connecting wires, devices offering resistance and capacitance depending on region of operation. And most of you might have studied that a PN junction diode is offering two types of capacitance, one in forward bias, other one is reverse biased. Diffusion and transition capacitance. And on resistance of device is also different for different region of operations. Not only PN junction. So BJT, when you are operating BJT in different region of operations, different capacitances, different resistances we are observing. And similarly, MOSFET also, every device is offering resistance and capacitance depending on region of operations. That means every device which is used in logic gate construction is offering some resistance and capacitance. Those are called parasitics. Not only this, for example, wire is also offering parasitics. So then you may be getting it out. How wire is offering capacitance? Simple way we need to understand is, see, you need to understand these things as electronic engineer. Yes, when IC is getting manufacturing, what happens generally is in base layer we are fabricating MOSFETs. For example, CMOS process we are using. So MOSFETs are manufactured. That means all the layers are created, diffused, drain and source, and everything is ready. After that, what you need to do? According to your connections, you need to make metals on these base layer, right? So if you are using millions of devices or millions of logic gates in our circuit, the available area is very small for IC. Then if you are trying to connect with metals, what you may be observing, one is connected, again one more, if you are passing on this, there will be shorts, then functionality will be different. Point should be understood correctly, right? So if it is not possible to complete all the connection in one layer, what we do? Completing the connection which are possible, then we are filling SiO2, right? SiO2, dielectric material. Then by pulling some more connections, some more wires up, then filling that SiO2, again we are completing some more connections. Still, it will not be sufficient. Again, pulling that connections which are not completed, then again dielectric material, again completing connections. Like that, I have used in my designs 12 metal layers. Till 20 nanometer technology which I worked on, there I have used 12 metal layers. Nowadays it is more than that. I think 14 or 15 metal layers people are using. And also there is a 3D IC manufacturing is going on. Now, what is that we have discussed? What we need to understand from this is, see, some metal layers are there, right? Metals are connected. Then what is it upon that dielectric material? Again, metal will be there in the next level. Then what is it here? These metals are carrying carriers. These carriers are separated with the dielectric material, then offering capacitance, right? Charge carriers separated with dielectric material. What will be there? Capacitance. That's what I've been saying, that due to metals also, there will be parasitics, resistance and capacitance offered. That is the reason, actually, there will be wire delay also. Wire delay also. Not only delayed due to devices which we are using in our logic gate construction, if there is any wire, a long wire, there will be delay due to this wire also. Reason for the delay is, what is that? Parasitics of metals. So if I extend more than this, sure, I may be into VLSI designs, so I would like to come out of this, right? Yes. Cadence software you can use, or you can use any, right? And for information, Vamshi Krishna, propagation delay is not fixed. Propagation delay is depending on what is the output load capacitance we are getting for a logic gate. That is decided by how many logic gates are connected to the output, that is fan out. And how much speed you are providing in input transition, that is input transition time and output load capacitance. Input transition time and output load capacitance have been deciding. That means environment where I am using this logic gate. There already characterized limits will be there. With respect to input transition time and output load capacitance, it will be provided lookup table for each and every logic gate. Then calculating what is the transition time possible on input, tool can do that. And what is the load capacitance possible by accumulating all the logic gates capacitances. Then it is able to calculate propagation delay. So propagation delay is not fixed. When we are saying the propagation delay of a logic gate is 2 nanoseconds, that is average value we are using to understand the concept. But in reality, it is not always 2 nanoseconds. Not only that, for A to Y, one propagation delay, for B to Y, another propagation delay. Sometimes rising delay is different, falling delay is different. All these I'm not discussing. You will be understanding all these after getting into VLSI, that is device and VLSI. You are going to study more and more EC students. Electrical students, it may not be there, but for EC students, you are going to study more and more about devices, right, in EDC and VLSI, right? You don't need to worry about that. Sai Pratyush, I work for Texas Instruments Bangalore, TI, and I work for one more company, service-based company. Now it is Maschip. I'm not discussing the design now, please. I need propagation delay analysis. That is the reason I'm explaining what I know. Please don't pull me into now industry things, right? Come out of that, please. Let us understand correctly. So we need to understand each and every concept in depth, right? So let us try to understand about propagation delay analysis. Are you there? Are you here? Yes. Sai Pratyush, are you working? Where do you ask me where I worked? Present is. Right, fine. Okay. Right. Now, this is one way of analyzing propagation delay effects. I hope everyone is understood. Now, let us see another way of analyzing propagation delay analysis. Let me draw that Y functionally. What do we mean by functionally? I'm not including propagation delay, simply functional output waveform I'm drawing. Point should be understood correctly. First waveform I'm writing what is that Y star I'm mentioning is nothing but without considering propagation delay effects, I'm drawing functional output waveform. For 0, 0 stable inputs, output is 0. For 1, 0, what is that here? Output is 1. I'm not including propagation. I don't know about propagation now. For 1, 1 also, OR gate output is 1. For 0, 1, OR gate output is 1. For 0, 0, OR gate output is 0. This is a OR gate output functionally. I did not include propagation. Wherever there is a change in the output, that must be delayed by delta. Or a simple way is move this Y waveform right side delta time. That's it. Entire waveform, just shift it. Or you can use that signal shifter. If you have done signals y of t minus delta, a positive shift, a positive delay. Exact functional output waveform must be delayed by propagation delay time. That's it. No more extra analysis is required to understand about propagation delay effects in our digital circuits. If you want to understand more about propagation delay, that you can do after completion of VLSI devices. Until that, hold on. So at this moment, to understand the propagation delay analysis, with respect to input variations, first we have drawn functional output waveform. Then this functional output waveform must be delayed by propagation delay time or shift it by delta time. Move it by, just throw it by delta time. So why actual we will be getting is this. What is it here? 0 is 0 only. It is 0 to 1. That means after propagation delay time. Shifting. Simple thing is a shifting waveform. It is again delta. This is what we have seen earlier also. This is simple way. What is it here? Simply drawing functional waveform shifted by propagation delay time. Simply drawing functional waveform shifted by propagation delay time. So better to follow this because there will be confusions if you have been analyzing input changes and output changes and so on and so. That is the reason always I suggest to my students draw functional waveform shifted by propagation delay time. Shifted by propagation delay time. Okay. Here, why we are not getting change here is already for 1 0 OR gate output is 1. Even though input is changing, what we are getting here 1 1 OR gate output is 1 only. Before this change in the input, OR gate output is 1. After this change in the input, OR gate output is 1. Is there any change in the output? No. If there is a change in the output due to changes in the input, there we need to consider propagation delay. But this input change is not giving any changes in the output. If there is no change in the output, there we don't need to consider propagation delay. What for we are getting propagation delay? If output node capacitance is charging or discharging. So already it is charged to logic 1. After this also it is 1 only. Is there any change in the capacitance charge or voltage across capacitor? No. Then if there is no change in the voltage across capacitor, why do we get transients there? No, there won't be any propagation delay. Even though input changes have occurred, here output is not changing. If output is not changing, means simple thing is output node capacitance voltage is fixed. It is already at logic 1. After that also it is 1 only. That means it is not changing. If it is not changing, no delay, because already output is 1, again output is 1, there is no change in the output, there won't be any change in the capacitor. Okay. Some people have been worrying about many things instead of subject. Please focus on subject. How to cover, when to cover, all these will take care. Because institute is running for more than 25 years and faculties have been working for more than 10 years and managers also have been working more than 10 years. They have been managing all the times. People, if you are worrying about all these initial days itself, what you can control yourself in November, December, check yourself. Because someone has messaged me how many days it takes to complete the syllabus. People are worrying about syllabus, not the depth of the subject. Right? So please don't disturb me in between, please, requesting. Because I do my duty. Please follow the class correctly. That is your duty. Please do do your duties, sir. We'll take care of, because managers are there and our director is there and they plan accordingly to cover the syllabus, sir. Right? So everything will be taken care by ourselves. So do your duties, sir. That is correctly. That will give you benefits, instead of concentrating on our duties. So we are getting paid to take care of all these things, sir. So we do that. Please focus on your duties, how to understand each and every topic which is covered. So completion of syllabus, what is there in that? I can complete the same digital subject in 2 full days. That means effectively 20 hours if it is offline. I can complete. The same I can talk more than 100 hours effectively. So I do balance all these things. I'll cover the syllabus. I'll complete the syllabus also. So if you are expecting completion of syllabus, sure, I can complete in 2 or 3 days. So don't expect me, don't give me that indication, sir. There are very good students in this class, sir, and people are interested in learning subject in depth. So please focus on subject, please. Right. Right. This is a output waveform when you are including propagation delay. When you are including propagation delay. Let me take one more example. A, it is Y. The propagation delay of inverter is 5 nanosecond. Propagation delay of AND gate is 2 nanoseconds. What will be the output waveform if A input is like this? If A is changing from 0 to 1, let me say that at T, what will be the output waveform including propagation delay effects? So what is given here? A, an inverter and AND gate. Inverter delay is 5 nanoseconds. AND gate delay is how much? 2 nanoseconds. What will be the output waveform Y including propagation delay? Including propagation delay. Yes, Chakrabarti, there will be difference. Yes, there will be different delays for different logic gates with different fan in as well as fan out also. So depending on its capability, there will be. I'm not asking how much delay is that. Just try to draw that output waveform because they are giving options with waveforms only. They are giving options with waveforms only. Ashutosh, I'm not asking any to the number, how much delay is that. So simply, I'm asking you to draw that waveform, sir, and I'll be drawing that waveform. Please verify. Please verify. Right. Now, what should I draw? Directly, I cannot draw Y because A is there and I need to have that A bar also. I need to draw A bar. What is that A bar? If A is 0, A bar is 1. A bar is 1. See, here A is changing from 0 to 1. A bar is changing from 1 to 0. See correctly, observe correctly. A is changing from 0 to 1. A bar is changing from 1 to 0. After how much delay? 5 nanoseconds. After 5 nanoseconds. Observe the effect of propagation delay correctly. What is it here? A is changing from 0 to 1. A bar is changing from 1 to 0, but not immediately after 5 nanoseconds delay. Because inverter delay is mentioned 5 nanoseconds. Inverter delay is mentioned 5 nanoseconds. Now, these two are inputs of AND gate. Let me draw that Y functionally. Let me draw that Y functionally. So, let me draw that Y functionally. For 0, 1, AND gate output is what? 0. For 1, 1, AND gate output is what? 1. And again, for 1, 0, AND gate output is 0. What we have drawn here? Output Y functionally. Output Y functionally. Now, what is this Y waveform? Without considering propagation delay, functional output waveform. To get actual output waveform, what should I do? Shift this functional output waveform by propagation delay time of logic gate. Which gate is that? AND gate output we have drawn. So AND gate delay should be considered for shifting. How much is that? 2 nanosecond. Shift this by 2 nanosecond. Just a minute. Right. So this is 2 nanoseconds. Because this change should be shifted by 2 nanoseconds. This is again 2 nanoseconds. How much is this? 5 nanoseconds. Observe this correctly. So most of you are saying that 0 time or 0 delay. The reason is A and A bar, it will be 0. Output is 0, you are saying. Functionally, output must be 0 always. But practically, with the effect of propagation delay, we are getting unwanted glitch, logic 1 for 5 nanoseconds. All this because of propagation delay. Why? A changes have arrived early, but A bar is not arriving with A changes. A bar is arriving after 5 nanoseconds. So, arrival of input at AND gate is not at common point of time. If A and A bar changes are occurring at common point of time, yes, output will be 0. But A is arriving early, A bar is arriving after 5 nanoseconds. In this 5 nanosecond duration, we are getting unwanted glitch. Try to understand correctly. Some of you or most of you are saying that it is output 0. Reason is functionally you are saying that A and A bar will be 0. What is it here? A and A bar will be 0. Correct. But practically with the effect of propagation delay, what we have observed is there is an unwanted glitch which is output 1 for 5 nanoseconds. The reason for that is already we mentioned. What is it here? Arrival of input is not at common point of time. If A and A bar are arriving at input of AND gate, yes, always AND gate output will be 0 only. But A changes have occurred, arrived immediately. A bar is arriving after 5 nanoseconds. In this 5 nanosecond duration, so we are seeing that unwanted glitch. Ravi Teja, wait, please. Wait. So how to eliminate this glitch, unwanted glitch? Simply, what is it here? Adding a buffer. How much delay? 5 nanoseconds. Then no problem. A and A bar will be arriving at common point of time. The glitch will be eliminated. All these things will take care in our designs that you are going to do later. But here, they won't ask you all this. Simply, they are giving input changes. They are asking what will be the output waveform. That's it. So with respect to gate and ESC, what is required here? How to draw that output waveform. Then later, how to include propagation delay analysis in adder circuits as well as counters and sequential circuits also we are going to see. Until that, hold on, right? So I hope everything is fine. I hope everything is fine. So always I suggest you for beginners on propagation delay analysis, simple thing is drawing input variations. With respect to input variation, draw functional output waveform. So delay this functional output waveform by propagation delay. That's it. Delay output waveform, functional output waveform. Right. Such questions we will be discussing. Kashyap, please wait. Such questions, whatever you are asking, how much delay and all such questions I will discuss later after getting into combinational circuit. Here, what we are learning is how to analyze propagation delay. Is it fine? Simple thing is getting input variations, drawing functional waveform, shifted by propagation rhythm. Signals x of t minus a, here y of t minus delta, a positive shift. Now, ten nanosecond delay for NOR gate, 20 nanosecond delay for XOR gate. What will be the output waveform V naught, including propagation effects? Let's say it is T naught. Right. Let me draw that first NOR gate output. Let me say it is X. Let me say it is X. What is X? Vi bar. Because NOR gate with Vi and Vi as inputs, Vi plus Vi whole bar. It is Vi bar. See correctly what is it here? NOR gate inputs are Vi and Vi only. Output of NOR gate will be Vi bar. It is complement of Vi. So initially stable inputs. What will be the output of NOR gate? 1 because here Vi is 0. Now here Vi changing from 0 to 1. Vi changing from 0 to 1. Now output of NOR gate will be changing from 1 to 0 because inversion after 10 nanoseconds. This is 10 nanoseconds. Check it correctly. Vi waveform is given. Now we are drawing that NOR gate output X, which is Vi bar. Vi bar we are drawing. Yes. So now these two are inputs of XOR gate. These two are inputs for XOR gate. Now let me draw that XOR gate functional output waveform. Point should be understood correctly. XOR gate functional output waveform. Yes, these two are inputs of XOR gate. Let me draw that XOR gate output V naught functionally. What is it here? 0, 1 XOR gate output is 1. For 1, 1 XOR gate output is 0. For 1, 0 XOR gate output is 1. For 1, 0 XOR gate output is 1. Right? This is a functional output waveform of V output. It must be delayed by 20 nanoseconds. What we have drawn till now, just a functional output waveform of XOR gate. Functional output waveform of XOR gate. Now, to get actual waveform, this waveform must be shifted by delta time. What is delta? 20 nanoseconds, which is for XOR gate. See once again, this functional output waveform must be moved or shifted right by 20 nanoseconds. So V output it is 1. Now this must be delayed by 20 nanoseconds. Then again the step here must be delayed by 20 nanoseconds. Clearly observe this, sir. From here to here, this edge is shifted by 20 nanoseconds. This edge also shifted by 20 nanoseconds. Check it correctly. The entire functional output waveform must be shifted by propagation delay. Propagation delay. Just shift that waveform by delta, which is 20 nanoseconds in this. So first what we have done, input waveform is given. First we have drawn NOR gate output. What is NOR gate output? Inversion, because NOR gate both the inputs are Vi, X equals to Vi bar. That means we are drawing that output waveform of X including 10 nanoseconds delay. And after that, these Vi and X are inputs of XOR gate. Then what we have drawn? Functional output waveform of XOR gate. This functional output waveform of XOR gate must be shifted by propagation delay of XOR gate. XOR gate propagation delay is how much? How much? 20 nanoseconds. The functional output waveform must be shifted by 20 nanoseconds. Right. So this is an actual waveform including propagation delay. So simple way is drawing functional waveform shifted by propagation delay. Signal shifting, you are very much familiar. Simply move that waveform, throw that waveform by propagation delay time. That's it. You'll get an actual waveform. Very good. Most of you have understood correctly. Try to focus on this. What we are doing, simply drawing that final gate input variations, then drawing functional output of a final gate, then shifted by propagation delay. Shifted by propagation delay. Right, we discuss some more questions on propagation delay from classroom practice questions, and the practice those first. So these are classroom practice questions of number systems. Try to solve one by one. Given 135 basics equals to, sorry, 135 basics plus 144 basics equals to 323 basics. Then x is equals to. Some simple questions are there. Most of you might have solved already. But if you are waiting to solve by me, I'm helping you here. So first one is what? See, first question is what? Read the question. 135 basics plus 144 basics equals to 323 basics. Then what is the value of x? Given equation is what? 135 basics plus 144 basics is equals to 323 basics. Then let me write that x square plus 3x plus 5. Why decimal equivalent of 135? X power 0, x power 1, x power 2. X square plus 3x plus 5. Plus again 144. What is it here? 1 into x square plus 4x plus 4 is equals to what we have here? 3x square plus 2x plus 3. And finally, what is it here? 3x square minus 2x square, x square, 2x minus 7x, it is minus 5x. So here 3, here it is 4, 5. So 3 minus 9, which is 6, is equals to 0. Right? So x square minus 6x plus x minus 6 is equals to 0. X common, x minus 6 plus 1 common, x minus 6 is equals to 0. X minus 6 into x plus 1 is equals to 0. So x is equals to minus 1 or 6. Minus 1 can't be the base, 6 is the base. With respect to digits, it is satisfying. With respect to decimal equivalents also, it will be satisfying. Most of you might have done this question correctly. Am I right? Am I right? Are you there? Yes. Very good. Right. So simple question, most of you might have answered already. Now second question, if you are observing the number of ones in 8-bit representation of minus 127 in 2's complement representation is a m, and that in 1's complement representation is n, what is the value of m is to n? What is it here? I need to represent minus 127 in 2's complement representation and 1's complement representation. The number of ones we need to observe in these two. Number of ones in 2's complement representation is m. Number of ones in 1's complement representation is n. Then what is that? M is to n. So simple thing is 127. If you want to calculate 127 magnitude is 2 6 3 the remainder is 1, 2 3 1 the remainder is 1, 2 1 5 the remainder is 1, 2 7 the remainder is 1, 2 3 the remainder is 1, 2 1 the remainder is 1. What is it here? 7 ones. So magnitude is 7 ones. If I make it 0, it is a plus 127. If I take one's complement, what we get here? Minus 127 in 1's complement representation. It is a minus 127 in 1's. If I take 2's complement of the same, what we get here? 1, 0, 0, 0, 0, 0, 0, 1. I hope everyone is able to write directly. It is minus 127 in 2's. Right? So the number of ones in 2's complement representation is m. The number of ones in 1's complement representation, n. M is to n is equals to 2 is to 1. think it is not visible. A number in 2's complement representation is x3, x2, x1, x0. The number when stored using 8 bits will be. What should I do? Originally, what is it here? It is a x3, x2, x1, x0. But I want to store in 8 bits. What should I do? Sign extension. What is an extension? MSB extension. X3, 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 X2, X1, X0. Because I cannot append zeros always. I cannot append 1 always. So what can I append? MSB of original number. So the number is in 2's complement representation means whenever it is required to represent using more number of bits, the only possibility is extension of bits. Extension of bits. Right? Answer is C. So next, the 2's complement representation of minus 539 decimal in hexadecimal is. Once again, fourth question, the 2's complement representation of minus 539 decimal in hexadecimal is. What is it here? Minus 539. We need to represent in 2's complement representation and convert into hexa. So first, let me represent plus 539. What we get here? 2 2s are 6s are 9s are. Remainder is 1. Then 2 1s are 3s are 4s are. Remainder is 1. 2 6s are 7s are. Remainder is 0. 2 3s are 3s are. Remainder is 1. 2 1s are 6s are. Remainder is 1. 2 8s are. Remainder is 0. 2 4s are. Remainder is 0. 2 2s are. Remainder is 0. 2 1s are. Remainder is 0. Then what is it here magnitude? 1 0 0 0 0 1 1 0 1 1. So append a 0, then it becomes a plus 539. In which representation? In all representations, because it is positive number. So excluding this 0, this is magnitude. Appending a 0, it is becoming plus 539. In which representation? In signed magnitude, in 1's complement, in 2's complement representation. What I would like to get minus 539 in 2's complement representation. Correct? So let me take 2's complement of this. What we get here? 1 0 1 0 0 1 1 1 1 0 1. What is this now? Minus 539 in 2's complement representation. Am I right? Minus 539 in 2's complement representation. Now, this must be converted to hexa. Then grouping 4 bits, and here number of bits is not sufficient. Appending with 0 will be wrong because appending with 1 is correct. Why? Originally MSB is already 1, so you need to extend with 1. Or as the number is negative, MSB should be 1, and extending that 1, value is not changing. Without changing value, you need to represent using more number of bits. Point should be understood correctly. What is it here? Without changing value, you need to represent using more number of bits. When we are converting from B to B power n, we need to group n digits, sets of n digits. There, if number of digits or number of bits is not sufficient, we need to extend the bits. If it is unsigned numbers, unsigned means only positive numbers, we can append with zeros. But here we are in signed numbers because it is minus 539. You need to extend with the MSB. Then 1101 is 13, which is D. 1110 14, which is E. 0101, which is 5. So it is DE5 hexa. It is DE5 hexa. Option C. Correct? Right. Most of you might have solved these questions, sir. I hope I have solved the same question in the class, sir. Same question I have solved in the class, sir. Please check your notes, sir. Yes, 312 divided by 20 equals 13.1. We have solved for base, sir. I have solved in the class, sir. Right. So the sixth question also we have discussed, sir. 1, 2, 3 base 5 is equals to x8 base y. how many X and Y solutions are possible. So we thought it is 4. Finally, we have confirmed it is 3. Do you remember? We thought it is 4. Finally, we have confirmed it is 3. Right. Same question we have discussed. And this simple hexadecimal to octal that you can do. Hexadecimal to binary, binary to octal, just match list 1, list 2. Simple question. I don't need to help you. This is also same. What is it here? Octal to binary is simple than earlier. Right. The statement word questions I'll discuss for ESC only. I will discuss. Just hold on. Try to understand this question. So rules for answering this question is statement 1 is true, statement 2 is true, statement 2 is explaining statement 1, then option A. Right? Statement 1 is true, statement 2 is true, statement 2 is not explaining statement 1, then option B. Statement 1 is true, statement 2 is false, then option C. Statement 1 is false, statement 2 is true, then option D. Let me repeat once again. Statement wide questions for ESC students. Statement 1 is true, statement 2 is true, statement 2 is explaining statement 1, then option A. Statement 1 is true, statement 2 is true, statement 2 is not explaining statement 1, then it is option B. Statement 1 is true, statement 2 is false, then option C. Statement 1 is false, statement 2 is true, then it is option D. So go through this. I will help you for ESC students. So let me take 11th question. Let me take 11th question. What is it here? 11x1y base 8 is equals to 12c9 base 16. Then the values of x and y are. See, 11x1y base 8. 11x1y base 8 is equals to, what is it? 12c9 base 16. 12c9 base 16. Then what is it? X and y values. Very simple. 1x1y base 8 is equals to, what is that we can write? This is base 16. Let me convert to binary. What we get here? 1 0 0 0 1 2 0 0 1 0 C 1 1 0 0 9 1 0 0 1. What is this binary equivalent of hexadecimal? But what is that equivalent we need? Base 8 equivalent we need. For that grouping 3 bits. Yes, 3, 3, 3, 3, and 3. Here 0 is not having significance, neglecting. So 0 0 1 is 1, 0 0 1 is 1, and 0 1 1 is 3, 0 0 1 is 1, 0 0 1 is 1. This is a base 8 equivalent. So 11x1y base 8 is equals to 11311. Then what is there in the position of x? 3. What is there in the position of y? 1. So x equal to 3, y is equals to 1. X equal to 3, y equals to 1. Simple thing. Hexadecimal to binary, binary to octal. Then comparing these two numbers which are in octal. Then we are getting respective variables values. Right. Yeah, most of you are requesting about this question. Read the question. A number n is stored in a 4-bit 2's complement representation as a A3, A2, A1, A0. It is copied into a 6-bit register, and after a few operations, the final bit pattern is A3, A3, A2, A1, A0, 1. Then the value of the bit pattern is 2's complement representation is given in terms of the original number n is as. So, simple thing is A3, A2, A1, A0 is representing n, which is in 2's complement representation. Then what is the value of A3, A3, A2, A1, A0? 1. That's it. So let us see what can be done. So n is A3, A2, A1, A0. Can you say what is the value of n? A3 minus 2 power 3 plus A2 2 power 2 plus A1 2 power 1 plus A0 2 power 0. Any questions in this? With 4, right? A3 MSB weight is minus 2 power n minus 1. Next remaining bits are positive weights. Minus 2 power n minus 1. N is 4. So minus 2 power 4 minus 1. Minus 2 power 3 plus A2 2 power 2 plus A1 2 power 1 plus A0 2 power 0. What is this? N. Now, after modifications, let me say that n dash. What we have? A3, A3, A2, A1, A0, 1. It is also in 2's complement representation. What is the value of this with respect to n? We need to calculate. So, if you are understanding concepts correctly, I can neglect A3. Why? For example, 10101 is there. Some value is there. What about 110101 value? Same, because extending these. That is also same. Here, A3 is there, A3 is extended. Without this also, it will be same. That's what we are doing. So, A3, A2, A1, A0, 1 value also equal to A3, A3, A2, A1, A0, 1. Here, I'm using sign extension property. Now, how many bits I have? 5 bits. Let me write that. A3 minus 2 power 4. A2 2 power 3. A1 2 power 2 plus A not 2 power 1 plus 1 into 2 power 0. Then in these 4, if I take 2 common, help me. A3 minus 2 power 3 plus A2 2 power 2 plus A1 2 power 1 plus A0 2 power 0 plus 1 into power 0 is 1. Then what is there in the parenthesis? N. Check it correctly. N plus 1. That's it. Most of you are struggling to answer this question. I think very simple question. Go with weights. You can answer easily. I will give you one more analysis after shift registers is completed. Until then, hold on. I will give you another explanation for this. Once shift register operation is completed, there I will explain this question once again. What are the operations it might have performed? That is also I will explain. Please hold on. So at this moment, let us go with the concept we have learned. What is there in that? Right? It is 2n plus 1. Why we have neglected A3 is it is just extension only. It is just extension only. As the extension is not changing the value, excluding that also value will be same, or you can proceed with 6 bits also. Shivalila. Question number 7. Am I missing question number 7? Yeah, I'll discuss. Okay. Okay, forgot. I'll discuss. Okay, is it done about this question? Anyone is having any doubt with respect to question number 12? If anyone is having any doubt with respect to question number 7, sorry, question number 12, question number 7, I'll discuss. Mangesh, yes. How many times you are typing the same? See, in all these 4, check it. In all these 4, if I take 2 common, if I take A3, what will be there? Minus 2 power 3 plus A2, 2 power 3 is there, it becomes 2 power 2. In this 2 power 2 was there, 2 power 1 it becomes here A0 2 power 1 is there, 2 already taken common, it is 2 power 0 plus 1. Or you can write that A0 into 1, not a problem. 2 power 0 is 1. So now what is this n 2n plus 1? Mangesh. Mangesh, are you done? Yes, thank you. Thank you for understanding. N is a number which is A3, A2, A1, A0, which is in 2's complement representation. Read the question correctly. Spend time on questions. So N is given, which is in 2's complement representation, which is A3, A2, A1, A0. If it is in 2's complement representation, we know the value of a number. That's what I am doing here. So it is 4-bit representation. So A3 minus 2 power n minus 1 plus A2 to power n minus 2, so and so. Applying that, I'm getting value of n. Then in this, after modifications, the number is A3, A3, A2, A1, A0, 1. So in this, I'm neglecting this A3 because it is a MSB extension. Value will not be changed because it is in 2's complement representation. Excluding this A3, how many bits we have now? 5 bits. With 5 bits, if you are calculating value A3 minus 2 power 4 plus A2 to power 3 plus A1 to power 2 plus A0 to power 1 plus 1 into 2 power 0, because number given. So in these 4, I can take 2 common. Then what we are getting here? A3 minus 2 power 3 plus A2 to power 2 plus A1 to power 1 plus A0 to power 0. So what is there in parenthesis? N. Right? So 2n remaining is plus 1. Sorry, I forgot about the 7th question. I'm going to that. Yes. 7th question. Is it discussed? Yes. What is it here? In 2's complement representations, how many numbers extra we can represent compared to signed magnitude and 1's complement? While discussing advantages of 2's complement representation. Advantages of 2's complement representation. While discussing advantages of 2's complement representation, I discussed one is a 0 representation, second one is expanded range. How much it is expanded? One number extra. Irrespective of number of bits, how many numbers extra you can represent? Only one number extra. In 2's complement representation over signed magnitude as well as 1's complement. See, once again, while discussing advantages of 2's complement representation, one advantage is 0 representation is having only one, and second one is expanded range. Then we discuss other point also. How much it is expanded? Only one number extra. See, statement. Let x be the number of distinct 16-bit integers in 2's complement representation. Let y be the number of distinct 16-bit integers in signed magnitude representation. Then x minus y. What is x minus y? How many numbers extra you can represent in 2's complement representation? How much extra is there in x over y? What is y? Numbers in signed magnitude. What is x? Numbers in 2's complement. That means x minus y is asked. How many numbers extra you can represent in 2's complement representation over signed magnitude? How many? Only one. Only one. One number extra we can represent in 2's complement representation compared to signed magnitude, compared to 1's complement. So I thought you might have solved this question easily because the property already I have discussed. Right. Anyone is having any question? Yes, I'll do. I will do. 4th one. Yes. What's the problem? Someone is asking me. Yes, most of you are replying correctly and attentively. People have been responding. Very good. Okay. Let me go with your questions, sir. So if you have any questions about these class and practice questions, first let us complete this. Then I'll open that slide. I will discuss doubts according to yours. So first, if you have at this moment, if you have any doubts with respect to these 12 questions, except a statement question. If you have any doubts, you can raise the hand. So can I assume that you don't have any doubts in these questions, sir? Shall I open the slides? Today's discussion. Okay. Eleventh question. What happened in the 11th question? Simple. It is hexadecimal, converting to binary, converting to octal, and we have both the sides octal, then comparing respect to digits. In X position, what we have? 3. In Y position, what we have? 1. Someone was asking. Vignesh. I will discuss logic gates. I haven't talked. I will discuss questions. Right? Try. I will discuss all the questions like this. First, you need to try. Sudha. Fine? Now, wait. One by one. Yes, Triveni.
Sir, in seventh question,
What is it?
in seventh question, sir.
Seventh question.
In seventh question, actually, if I have in sign magnitude representation, I take, for example, I take minus 127 to plus 127.
Okay.
In two's complement, I take minus 128 to 127.
127.
Yeah. In x minus y means minus 127 to plus 27, and in both are times,
Don't subtract the value. How many numbers extra you are representing?
one will be extra.
One number extra. Which one is that? Minus 128.
Yes.
One is extra, right?
Yes, yes.
That's what is asked. Number of distinct 16-bit integers can be represented in 2's complement representation with x. That in sign magnitude representation is y. How many numbers is x?
So
What is the
no
value is not asked.
Okay, sir. So no need to do addition and all, right? Only
Yes,
just
one number extra we are representing, right?
Okay.
Right?
Because I think x minus y means I have to do any subtraction or like that means I have to
No,
get minus 1.
Read the question twice or thrice. You will understand more.
Okay, sir. Thank you.
Please read the question correctly.
Okay, sir.
You will understand more. Right. Thank you. Yes. Okay. Nagalingeshwar Rao. Yes,
Hi, sir. Good evening, sir.
very good evening.
Sir, can you tell how to perform XOR operation between two hexadecimal numbers?
XOR operation means it is a digital logic gate, right?
Between
If you
two
are,
hexadecimal numbers.
see. Oh, hold on. When you asked, give me a chance to
Okay,
explain,
sir.
right? So now what you are asking is if C is there, XORing with 8. That's what you are saying. Am I
Yes, sir.
right? Then 1100 XORing with 1000. Respective bits 0, 1, 0, 0. They might be expecting this,
Okay, sir.
right? Done.
Okay, sir. Is any other alternative, sir?
The only thing is XOR operation can be performed on ones and zeros.
Okay, sir.
Then I have to get ones and zeros of respective numbers.
Hexadecimal should be converted to binary and then we have to perform
Binary
XOR.
only we can perform XOR operation, right?
Okay, sir.
Right.
Yes.
Ujjwal Chandan.
Good evening, sir.
Very good evening.
So 11F slide.
In
11F.
okay.
So my question is, in this switching example,
Hmm.
is it completely identical to SOP?
Yeah.
If I
Yeah,
have
you can construct a POS also.
no, like I want to construct A XOR B XOR C in switching. So should I use the SOP?
Actually, it becomes very complex. In reality, for your information, we don't have that multi-input logic gates. We have only 2-input logic gates.
Okay,
Generally, we use.
that was all, sir. Thank you.
Ashish. Ashish.
Good evening, sir.
Very good evening. Tell me.
Sir, answer 30th. Last question.
Yes, slide.
Yes, sir, 30th.
Okay.
Yes, sir. How, sir? How X is VI bar? I'm not getting it.
NOR gate with VI and VI input. What we get VI plus VI whole bar.
Oh, it's not. Oh, sorry, sorry, sir.
Not XNOR gate.
Not okay. Huh.
You thought it is XNOR gate?
Oh, yes, sir. Sorry, sir. Thank you, sir.
Why you are saying sorry? Say sorry to yourself because you understood wrongly.
Thank you.
Right. Manikanta.
Good evening, sir.
Very good evening, Manikanta. Tell me.
In 16th slide,
16th slide. Okay.
A XNOR B XNOR C equal to
Uh,
A XOR B XOR C, sir.
this
A
is
XNOR
equals
B
to
XNOR.
C. When you are pronouncing, be clear. A XNOR B XNOR C are you saying or A XNOR B XNORing with C? Pronunciation must be different. When you are saying that A XNOR B XNORing with C, this is there. When you are saying that A XNOR B XNOR C, it is this one. Which one you are talking?
Sir, in this A XNOR B XNOR C, sir. A bar B bar C bar plus A bar B C.
Hmm.
In the circuit diagram, you have no drawn, sir.
You want to draw the 3-input circuit or what?
Sir, three input XNOR circuit diagram, sir.
What circuit diagram? Switch diagram?
A XNOR B XNOR C.
Yeah, okay. What happened? What happened?
Sir, in this
Huh.
3 inputs is given to XNOR gate.
Yes, sir.
Output is A XNOR B, XNOR C and XNOR C, sir.
This
But
is
it-
different. This is different than that. What is that here is what I discussed already in the class is this. Just check it. These two are not same.
Yes, sir.
See, not this. This one. These two are not same, right?
Yes, sir. These two are not same.
That's what you are asking, right?
But in this expression, A, B, C given to XNOR input, sir.
Okay.
Output will be
Uh,
A XOR B NOR C ga, sir. XNOR C ga, sir.
I did not understand. Sorry, please. Once again,
3 inputs are given to directly XNOR gate, sir.
XNOR gate.
Output will be A XOR B XNOR C, sir.
Why? Why?
Sir?
Why? Why I'm asking?
Sir, prove, sir. 3 inputs are given to XNOR gate. Why even inputs are given 1, sir? Odd inputs are also 1, sir.
All inputs are ones, also output is one, you are saying?
No, sir. Even number of inputs are given. Even number of ones, output 1, sir. You say.
Yes, sir.
I say odd number of ones is output 1, sir.
Why? Then what is the difference between XOR and XNOR?
Yes, sir. Why difference XNOR odd gate గా, sir. 3 inputs ఇచ్చినప్పుడు.
ఏమంటున్నావు ఒకసారి క్లియర్ చెప్పు నాన్న, నాకు అర్థమవుతుంది తెలుగులో, నువ్వు చెప్పు పర్లేదు, ఇప్పుడు వింటాను. నువ్వు కష్టపడుతున్నావు, నాకు చెప్పు ఏంటి?
సార్ 3 ఇన్పుట్స్ ఇచ్చినప్పుడు
ఆ,
3 ఇన్పుట్స్ ఎట్ ఏ టైం XNOR గేట్ కి ఇచ్చినప్పుడు
ఆ. ఏమవుతుంది చెప్పు.
అవుట్పుట్ విల్ బి A XOR B XNOR C, సార్.
అంటే ఎక్స్ప్రెషన్ ఎలా రాస్తావు, ఎందుకు అలా రాయాలి, ఏంటి రీజన్ ఏంటి?
XOR గేట్ కి నాట్ గేట్ అప్లై చేశారు సార్ మీరు.
అవును.
A XNOR B XNOR C కి హోల్ బార్. A XOR B XOR C హోల్ బార్, సార్.
అవును.
You have to prove this A XNOR B XNOR C will come, sir.
అంతే వస్తుంది, అందులో డౌట్ ఎందుకు, అదే వస్తుందా? ఏమైంది ఇప్పుడు? ఇప్పుడు
NOR gates, XOR gates will
చూడు,
come, sir.
నేను
A
చెప్తాను,
XOR B.
నేను చెప్తాను నిన్న, నేను చెప్పిన తర్వాత ఇನ್ನು ఒకసారి ఇక్కడ ఏం రాసామో చూడు ఒకసారి టేబుల్.
Yes, sir. 0 1 1 0 1 0 0 1, sir.
మరి దీంట్లో ఏం రాయాలి, కాంప్లిమెంటే కదా రాయాల్సింది.
సార్ కాంప్లిమెంట్ సార్, కానీ అవుట్పుట్ వచ్చేసరికి A XOR B XNOR C, సార్.
నువ్వు అది ఎందుకు పట్టుకొని ఉన్నావు నాకు చెప్పు ఒకసారి.
సార్ దీన్ని ప్రూవ్ చేయండి సార్. వచ్చింది
దేన్ని ప్రూవ్ చేయాలి, ఎందుకు ప్రూవ్ చేయాలి, నాకు అర్థం కావట్లేదు నీకు. దేన్ని ప్రూవ్ చేయాలి?
A XOR B XOR C హోల్ బార్ ని ప్రూవ్ చేస్తే
ఏం ప్రూవ్ చేయాలి, దాన్ని
2
ఏం
ఇన్పుట్స్
ప్రూవ్ చేయమంటున్నావు? అర్థమవుతుందా నేను చెప్పేది? ఏం ప్రూవ్ చేయమంటున్నావు ఒకసారి నాకు చెప్పు. మణికంఠ కుమార్,
ఎస్ సార్.
ఏం చేయమంటున్నావు చెప్పు నన్ను.
సార్ ఇప్పుడు A XOR B XOR C హోల్ బార్ ని ప్రూవ్ చేస్తే
ఒక పని చేస్తావా ప్లీజ్?
సార్
నువ్వు ఏదైతే ఎక్స్పెక్ట్ చేస్తున్నావో ఒకసారి దాని మీద పేపర్ మీద రాసి నాకు వాట్సాప్ చేయవా ప్లీజ్?
ఓకే సార్.
నాకు ఏమీ అర్థం కావట్లేదు, నువ్వు ఏమంటున్నావు, ఏం ప్రూవ్ చేయమంటున్నావు నువ్వు? ఇది అంటున్నావు, అదే తీసుకెళ్ళి నేను రాశాను ఇక్కడ చూడు ఒకసారి. ఇప్పుడు 3 ఇన్పుట్ XOR రాసిన ట్రూత్ టేబుల్ ని కాంప్లిమెంట్ చేసి నేను ఇక్కడ రాశాను. నువ్వు అదే చెప్తున్నావు, అదే నేను చేశాను, మళ్ళీ ప్రూవ్ చేయమంటున్నావు ఏంటి? ఈ టేబుల్ ని ప్రీవియస్ XOR టేబుల్ ఇక్కడ కంపేర్ చేస్తే వచ్చేది అదే కదా, ఇంకేం ప్రూవ్ చేయమంటున్నావు? ఎలా ప్రూవ్ చేయమంటున్నావు? నేను చెప్పింది ఏంటంటే, నేను ప్రూవ్ చేయాల్సింది ఏంటంటే ఇది ఏంటది, ఇది. దీని ఒక సమ్మరీ కింద నేను ఎక్కడ రాశానంటే ఇక్కడ రాశాను. XOR followed by XOR is giving 3 input XOR. XNOR followed by XNOR is not giving 3 input XNOR.
సార్ టేక్ సెకండ్ ఎగ్జాంపుల్ సార్.
ఏ ఎగ్జాంపుల్ ఇదే కదా,
ఎస్ సార్.
ఇదే కదా నేను చెప్పింది, ఇది కాదు అని చెప్తున్నా కదా. ఈ రెండు సేమ్ కావు. ఇక్కడ ఒక లైన్ ఉంది చూడు ఒకసారి.
సార్ ఈ రెండు సేమ్ కావు సార్.
ఇంకేంటా నీ బాధ?
ఈ రెండు సేమ్ కానప్పుడు అవుట్పుట్ అనేది ఏఎక్స్ నార్ బిఎక్స్ నార్ సి ఎలా వచ్చింది సార్? ఫస్ట్ 2 ఇన్పుట్ నార్ ఎక్స్ నార్ గేట్ కి అనదర్ ఇన్పుట్ ఎక్స్ నార్ గేట్ పెడితే ఏఎక్స్ నార్ బిఎక్స్ నార్ సి విల్ కమ్ సార్.
రాదు కదా, రాదని చెప్తున్నా నేనే.
మరి రానప్పుడు అక్కడ అవుట్పుట్ ఏఎక్స్ నార్ బిఎక్స్ నార్ సి ఎలా అయింది సార్?
మరి ఇదేంటి నాన్న, ఈ నార్ గేట్ ఇదేమవుతుంది? దీన్ని ఏమంటావు మరి? ఇది కూడా రావట్లేదు, మరి దీన్ని ఏమంటావు?
సార్ నా డౌట్ అదే సార్. మరి
అదే కదా నేను చెప్తుంది కూడా.
రాదు
నువ్వు అలా
కాబట్టి
కావాలని చెప్పేది
దాన్ని
చెప్పేది నాన్న, ఇది
చెప్పండి సార్.
రాదు అని నేనే చెప్పాను. ఇలా చేయకండి అని నేను చెప్తున్నాను. దీని ఫంక్షనాలిటీ నేను డిఫైన్ చేశాను. దీని ఫంక్షనాలిటీ ఎక్కడ డిఫైన్ చేశాను? నెంబర్ ఆఫ్ వన్స్ అబ్జర్వ్ చేశాను.
నెంబర్ ఆఫ్ వన్స్ అబ్జర్వ్ చేసినప్పుడు అవుట్పుట్ ఏఎక్స్ నార్ బిఎక్స్ నార్ సి కాదు కదా సార్. కాదని మీరే చెప్తున్నారు. మళ్ళీ అక్కడ ఏఎక్స్ నార్ బిఎక్స్ నార్ సి అని చెప్పి అవుట్పుట్ వన్స్ అని వేశారు. ఈవెన్ నెంబర్ ఆఫ్ వన్స్ ఉన్నప్పుడు అవుట్పుట్ 1 వచ్చింది అన్నారు.
ఇక్కడ కన్ఫ్యూజ్ అవుతున్నావు చూడన్నాను ఒకసారి. నువ్వు ఏదో స్టిక్ అయి ఉన్నావు, అదేదో చెప్పు నాకు. నాకు ఏమంటున్నావు నాకు అర్థం కావట్లేదు.
సార్
ఇది ఇలా రాశాను. ఈ ట్రూత్ టేబుల్ తప్ప కరెక్టా?
తప్పు సార్.
ఎందుకని?
3 ఇన్పుట్స్ ఎట్ ఏ టైమ్ ఎక్స్ నార్ గేట్ కి ఇచ్చినప్పుడు అవుట్పుట్ మీరు ఏఎక్స్ నార్ బిఎక్స్ నార్ సి రాదని మీరే చెప్పారు.
నేను 3 ఇన్పుట్ ఎగ్జినార్ సపరేట్ డిజైన్ చేస్తానని చెప్తున్నాను. ఈ 3 ఇన్పుట్ ఎగ్జినార్ ఫాలోడ్ బై ఎగ్జినార్ చేయట్లేదు అని చెప్తున్నాను. అర్థమవుతుందా? నేను ఇలా చేస్తే తప్పు అవుతుంది, ఇలా చేయకు అని చెప్తున్నాను. నువ్వు ఇది కావాలంటే దీన్ని ఇలా చేయకు, ఇది కరెక్ట్ కాదు అని చెప్తున్నాను. అర్థమవుతుందా?
ఓకే సార్.
సరిగ్గా ఇది ఇలా చేస్తే ఇది రాదు అనా? సరిగ్గా ఇది చేయకు అని చెప్తున్నా నేను. ఇలా చేస్తే ఇది రాదు, ఇది వేరు. అలాగే ఇవి కూడా చూడు. ఇంతేకాదు వీటిని కూడా ఇలా ఇంప్లిమెంట్ చేయొద్దని చెప్పాను. ఇప్పుడు నార్గేట్ 3 ఇన్పుట్ నార్గేట్ రావాలంటే ఇలా చేయకు అని చెప్పా కదా. అదే 3 ఇన్పుట్ నాండ్ కావాలంటే కూడా ఇలా చేయకు అని చెప్తున్నా నీకు. అర్థమవుతుందా? ఇలా చెయ్యకు అని చెప్తున్నా. నువ్వు అలాగే చేస్తానంటావు ఏంటి? అలా చేసి నాకు అలా ప్రూవ్ చేయమంటావు ఏంటి? అలా చేస్తే రాదు అని క్లియర్గా చెప్తున్నా కదా. ఈ 3 ఇన్పుట్ నార్ వేరు, ఈ సర్క్యూట్ వేరు. 3 ఇన్పుట్ నాండ్ వేరు, ఈ సర్క్యూట్ వేరు. 3 ఇన్పుట్ ఎక్స్నార్ వేరు, ఈ సర్క్యూట్ వేరు. అర్థమవుతుందా?
ఓకే సార్.
ఏదో స్టిక్ అయి ఉన్నావు, అదే చెప్పు నాకు. అందుకే నువ్వు ఏమైనా ఉంటే రాయి, పేపర్ మీద రాయి, నాకు వాట్సాప్ చేయి, నేను చెప్తాను.
ఓకే సార్.
ఎందుకు వస్తుందో నీకు డౌట్ నాకు తెలుసు. చెప్పమంటావా?
సార్
నువ్వు చదివింది కూడా చెప్తాను. చదివింది కాదు, ఎక్కడ చదవలేదు, ఎవరో చెప్పింది చెప్తున్నాను. ఎందుకు అంటే ఆడ్ నెంబర్ ఆఫ్ ఇన్పుట్ ఉన్నప్పుడు 3 ఇన్పుట్ ఎగ్జార్ ఈక్వల్స్ 3 ఇన్పుట్ ఎగ్జార్, 5 ఇన్పుట్ ఎగ్జార్ ఈక్వల్ 5 ఇన్పుట్ ఎగ్జార్ అని చదివింటావు. అందుకే చెప్తున్నాను, అది తప్పు కాబట్టే చెప్తున్నాను. దాని ప్రూఫ్ ఏంటి అంటే ఇక్కడ చూడు, ఒక్కసారి చూడు, ఇది చూడు. ఇదే క్వశ్చన్, ప్రీవియస్ గేట్ క్వశ్చన్. నువ్వు అలా కనుక చదివి ఉంటే, ఒకవేళ 3 ఇన్పుట్ ఎగ్జినార్ ఫంక్షన్ 3 ఇన్పుట్ ఎగ్జార్ ఫంక్షన్ సేమ్ అయితే, అంటే ఆడ్ నెంబర్ ఆఫ్ వన్స్ ఉన్నప్పుడు అవుట్పుట్ కనుక 1 వస్తే ఎగ్జార్ ఫంక్షన్ లో కానీ ఎగ్జినార్ ఫంక్షన్ లో కానీ ఆప్షన్ ఏ కరెక్ట్ అవుతుంది, ఆప్షన్ బి కరెక్ట్ అవుతుంది, ఆప్షన్ సి కూడా కరెక్ట్ అవుతుంది. చెక్ చేసుకో. డి ఒక్కటే రాంగ్ అవుతున్నా. చెప్పేవాళ్ళకు ఉండాలి, మనం విన్నప్పుడు కూడా కొంచెం జాగ్రత్తగా వినాలి. అర్థమవుతుందా? చెప్పేవాళ్ళు ఏం చెప్పినా కూడా మనము వాళ్ళు బ్లైండ్ గా ఫాలో అవ్వకూడదు. సరే చూడు, క్వశ్చన్ చూడు ఒకసారి. అలాగే కాకుండా ఇంకా క్లాస్ రూమ్ ప్రాక్టీస్ క్వశ్చన్స్ ఉన్నాయి, రేపు చెప్తాను నీకు.
ఓకే సార్.
సరేనా? ఎవరి దగ్గర చదువుకొని బ్లైండ్ గా ఫాలో అయ్యి నన్ను అది ప్రూవ్ చేయమంటే నేను చేయలేను. నేను చెప్పింది కరెక్ట్ కాదో ప్రూవ్ చేయమంటే నేను చేస్తాను. చూడు.
థ్యాంక్ యూ సార్.
అర్థమైందా? నాకు అర్థమవుతుంది, నీ మాటలో నాకు అర్థమవుతుంది. అందుకే నేను చెప్పాను, నీకు ఏం డౌట్ ఉందో పేపర్ మీద రాసి నాకు పంపించున్నా అని చెప్తున్నాను. ఎందుకంటే ఐ కెన్ రీడ్ యువర్ మైండ్. ఎందుకంటే టెక్స్ట్ బుక్ లో ఇవ్వలేదు అది, కానీ కొందరు అలా చెప్తారు. ఆ చెప్పడం ఏంటో నాకు తెలుసు, చెప్పక్కర్లేదు ఎక్కడి నుంచి చదివా కూడా. అర్థమవుతుందా అన్న?
ఓకే సార్.
రైట్. అంటే నేను చెప్పింది కరెక్ట్ కాదో నన్ను ప్రూవ్ చేయమని చెప్పు, కానీ నువ్వేదో అనుకుని అదే ప్రూవ్ చేయమని నేను చేయలేను. రైట్.
ఓకే
సో
సార్.
ఈ క్వశ్చన్ లో మరి ఏం చేస్తావు చెప్పు నువ్వు? ఏ తీసుకుంటావా, బి తీసుకుంటావా, సి తీసుకుంటావా? సబ్స్టిట్యూట్ చేసి చూడు.
ఓకే
ఒకవేళ
సార్.
నువ్వు చెప్పిన స్టేట్మెంట్ కనుక కరెక్ట్ అయితే ఈ క్వశ్చన్ లో ఆప్షన్ ఏ కరెక్ట్, ఆప్షన్ బి కరెక్ట్, ఆప్షన్ సి కరెక్ట్.
ఓకే
వింటున్నావా?
ఎస్ సార్.
చూడు ఒకసారి. మరి ఈ క్వశ్చన్ కి 2 మార్కుల క్వశ్చన్ ని ఏం చేద్దాం మరి? వదిలేద్దామా?
నేను పేపర్ మీద పంపిస్తా సార్ చేసి ఒకసారి.
అదే నువ్వు పంపించు, నేను మాట్లాడతాను. నువ్వేం చేసావో అర్థమైంది, నువ్వేమనుకుంటావు నాకు అర్థమైంది. అర్థమైందా?
ఎస్ సార్.
ఒక్కసారి నువ్వు ఏమనుకుంటావు అది పంపించు. అలాగే ఈ క్వశ్చన్ గుర్తుపెట్టుకో ఒకసారి మైండ్ లో.
ఓకే సార్.
ఒకసారి స్నాప్షాట్ తీసుకొని నీవు అనుకున్నట్టుగా ఈ ఆప్షన్ సబ్స్టిట్యూట్ చేయి. నువ్వేమనుకుంటావు ఎగ్జార్ ఫంక్షన్ ని అది అనుకుని ఈ ఆప్షన్ సబ్స్టిట్యూట్ చేయి. అప్పుడు నువ్వు ఏ ఆప్షన్ కరెక్ట్ చూస్ చేసుకుంటావో చెప్పు నాకు.
ఓకే సార్.
సరేనా?
థాంక్స్.
సరేనా? టెన్షన్
Sir.
పడకు, ఏం కాదు, కంగారు పడకు. ఎక్కడో తప్పు జరిగింది కదా, ఆ తప్పు సరిదిద్దాం మనం. సరేనా?
ఓకే సార్.
తప్పును తప్పుగానే పట్టుకొని తిరగద్దు, మళ్ళీ
ఓకే సార్.
సరిదిద్దాం, కరెక్ట్ చేద్దాం. ఒక క్వశ్చన్ వల్ల మన జీవితం మారిపోవచ్చు, ఒక కాన్సెప్ట్ వల్ల జీవితం మారొచ్చు. అందుకని మార్చేద్దాం, అంతా మార్చేద్దాం. సరేనా?
ఎస్ సార్.
మార్చకపోతే ఇక తప్పే జరుగుతుంటుంది ఎప్పుడు. అర్థమవుతుందా?
ఎస్ సార్.
తప్పు చేయొద్దు, కరెక్ట్ నేర్చుకుందాం, కరెక్టే చేద్దాం. బీ కాన్ఫిడెంట్, ఐఎమ్ దేర్ టు హెల్ప్ యూ. నువ్వు ఎవరో చెప్పిందని నేను ప్రూవ్ చేయమంటే నేను చేయను. నేను చెప్పింది కరెక్ట్ కాదు చెప్పమంటే నేను చెప్తాను, ఎగ్జాంపుల్ కూడా చూపిస్తాను. సరేనా?
ఓకే సార్.
సరేనా? ఇందులో ఈవెన్ నెంబర్ ఆఫ్ వన్స్ అయితే మాత్రమే ఒక ఆప్షన్ ఉంటుంది. అదే ఆడ్ నెంబర్ ఆఫ్ వన్స్ కనుక అబ్జర్వ్ చేసావు అనుకో ఎగ్జార్ గేట్ కి,
ఎస్ సార్.
ఆప్షన్ ఏ కరెక్ట్ అవుతుంది, ఆప్షన్ బి కరెక్ట్ అవుతుంది, ఆప్షన్ సి కూడా కరెక్ట్ అవుతుంది. సరేనా?
ఓకే సార్.
అర్థమైందా? సరే, ఒకసారి నాకు కాల్ చేయనా, నువ్వు నా నెంబర్ ఉంది కదా,
ఎస్ సార్.
నాకు ఒకసారి కాల్ చేయి, నేను చెప్తాను ఏంటో కూడా చెప్తాను, మొత్తం నీకు డీటెయిల్ గా చెప్తాను నీకు. సరేనా?
ఎన్ని చేయమంటారు సార్ కాల్?
నేను క్లాస్ అయిపోద్ది కదా, అయిపోయినప్పుడు చెయ్యి.
ఓకే సార్.
ఇప్పుడు అయిపోద్ది కదా, నేను ఇప్పుడు సైన్ అవుట్ చేస్తాను కదా, అయిపోయినా
Yes, sir.
చేసేస్తాను.
ఎస్ సార్.
రైట్. పవన్ కుమార్.
Sir, 26 students, sir.
What is that?
26, sir. 26.
Page number, frame number 26. Yes.
Sir, in this, why can't it be BC bar plus AB bar C bar, sir?
Once again, tell me what is that?
BC bar plus AB bar C bar.
A, B bar, C bar.
C bar.
C bar common. What we get? B plus A, B bar, right?
Yes, sir. Yes, sir. Yes, sir. I got further simplification. Is
Okay. Right. Thank you. Thank you for understanding. One step. Right?
yes, sir. Yes, sir.
Okay.
Sir, hello. Hello, sir.
Yes.
Sir, I have another question from number system, sir.
Okay. Tell me.
Sir, can you write minus 0.375 using ones complement, sir? Is there any complement representation?
Actually,
fractions?
it is fractions, floating point representation. I'll talk about that. Floating point representation. Fractions will be represented with floating point representation.
No, sir, my question primarily is, does ones complement representation exist, sir, for negative fractions?
No. That we represent with floating point representation.
No, sir. Actually, I tried for minus 0.375 to represent.
Whatever you are doing is wrong. Whatever
Okay,
you
sir.
are doing is wrong.
Okay, sir.
Right. For fractions, we go with the floating point representation. There are limitations if you are trying with that. Problems will be there.
Okay, sir. Thank you, sir.
Yeah. Annapurni.
Good evening, sir.
Very good evening, ma.
Sir, I have a doubt in the 7th question of the classroom problem, sir. Seventh question.
Of number systems or
Number systems, classroom problems.
I ask you to
Sorry, sir.
So wait, then I have to open the slides again.
No, actually, I am having a doubt. If it is x minus y, if it is x minus y, then the answer is 1. Then what about y minus x also? Answer is 1 only.
So -1.
Sir, but in x minus y, it's coming like -1, sir, because it is 2's complement minus it's 1's
So
complement. right?
once again. Please, if you have questions with you, please go through that. It is not asked what is the number you are representing, right? What is asked, how many numbers you can represent. The number of distinct 16-bit integers can be represented in 2's complement representation is x. There is nothing but how many numbers it can be represented. It is not what is the number. Be clear about this. For example, see, with 4 bits, in 2's complement representation, how many numbers can be represented? -8 to +7. Help me. How many?
I didn't get it, sir. Can you come again?
So using 4 bits in 2's complement representation, how many numbers you can represent? Range is -8 to +7. How many numbers?
2's complement means it's -8 to 7 only. 2's complement.
-8 to +7. How many numbers you are representing?
1.
How
I
many
didn't get
numbers?
your question. Sorry.
How many distinct numbers can be represented using 4 bits? Can't you count -8, -7, -6, -5, so and so?
Okay. There are 8 bits. Hello.
Not 8 bits. How many numbers you can represent? Annapurni. -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7.
Okay, it's 16.
Yeah. If it is -7 to +7, how many?
14.
15, 0.
15. Yes, yeah, 15.
16 minus, 15 minus, 16 minus 15, how much? So for example, instead of 16 bits, it is mentioned 4 bits only. X will be 16, Y will be 15.
Okay.
Numbers. How many numbers you can represent?
So 1, sir.
What is that?
1. X minus y is 1.
That's what we are getting, right? There also.
Okay. I got it, sir.
Right. Thank you. Yes. Saidamma. I enabled your account to talk. Saidamma. Okay. Pallavi.
Hi, sir. Good evening, sir.
Very good evening, ma. Tell me.
Sir, in this particular page, there are 3, like A, B bar, this was written. There are, how to say, sir, we need 4 number like this now to solve. Will you please again solve this?
Which one? This one?
This one, sir. Yes, sir.
Okay. What is the expression of this? You are talking about this only?
Yes, sir. Yes, sir.
Right. What is the expression of this, sir? A, B bar, C bar, right?
Yes, sir.
A, B bar, C bar. Plus, what is the expression of this middle one?
Is A, B, and C complement.
C bar. A, B, C bar, right?
Yes, sir.
And what about this one?
It's A complement.
A
A
bar,
bar,
C
C
bar.
bar, and B.
A bar, B, C bar.
C bar.
Now, if you are observing, in these two, what we can take common?
A, C bar.
Then B bar plus B
B.
plus A bar B, C bar. Then what we get here? A C bar plus A bar B C bar.
Yes.
Otherwise, we can have other possibility. What is that? It can be taken common B C bar.
Yes, sir.
So another one, what is it here? So see, just a minute. I forgot to. In these two, what we can take common?
BC bar.
BC bar. If I take BC bar common, what we are getting? A plus A bar.
A
C bar is 1. Finally, C bar plus BC bar is the expression, right?
Yes, sir. We can take 2 times each.
That's what I've been saying, that x plus x is x only. You can write any number of times.
Okay, sir.
Boolean algebra, right?
Yes, sir. Yes, sir.
Yes.
Yes, sir. Thank you, sir.
Yes. Tasni. Hello. Hello.
Hello. Sir, can you hear me?
Yeah, tell me.
Sir, in this current slide, can I write this as A C bar plus A bar B C bar?
Still, minimization is possible, right? What do you want to write? What do you want to write? A C bar plus
B C bar. A bar
A bar B C bar,
B
right?
C bar.
In these two, C
Yeah.
bar common possible, right?
Yeah.
Then what you can write? A plus A bar B.
Distributive.
Yeah, distributive. Again, A plus A bar and with A plus B, right?
Yeah.
A plus A bar is 1. C bar and with A plus B. Then again, we are getting same. A C
Yeah,
bar
okay.
plus B C bar.
Thank you, sir. I just want to confirm whether it's right or not.
Right, right. 100% right.
Thank you, sir. Thank you.
Very good. Yes. Manisha.
Good evening, sir.
Very good evening, ma.
Sir, I have a doubt in frame number 19, sir.
Page number 19. Okay. What happened?
Sir, not 19, sir. It's 25, I think.
What is that?
2020.
Okay.
Sir, not this one. Sir, there, like, you solved some bits now, sir. Like, all these.
Tell me, tell me.
Sir, the previous slide, sir.
This one only.
Sir, here. Sir, here you got like you solve this now, sir. A bar B plus AB bar plus AB. There you took AB 2 times, right, sir? Like you can use, like you said that we can use 2 times.
Is it wrong?
Hello? No, sir, not like that. But I got B, sir. By taking once, we can get B, sir. So that's my doubt.
So, can't we use multiple times one term in Boolean algebra? We can use it. Or if you want to write it, write AB plus AB. If I write it twice, will it be a problem?
No, sir.
That's the problem. When there is no problem, yes, we can do.
Okay.
If I write AB plus AB, when functionality is not changing, what is the problem?
Okay, sir.
Right. X plus X equals to X in Boolean algebra.
Okay, sir.
X plus X is not 2X. X plus X equals
Sir,
X.
like, sir, I have a doubt. Like, if we use two times, then if the expression, the result of that expression may be different answer, then what will happen, sir? Means we will get two answers, right, sir?
It will be same. It will be same. Let me tell you that if the K map is like this, what do you do?
Yes, sir.
Why are you doing this twice then?
Okay, sir.
Understood?
Okay, sir.
Right?
Okay, sir. Sir, I have another doubt in 25th slide.
Okay.
Sir, here you concluded that C plus AB C bar equal to C plus AB bar, right, sir? I didn't understood that step, sir.
This one,
Yes, sir.
again, C plus AB C bar. What I write? C plus AB, distributive law.
Yes.
C plus C bar.
How, sir? I didn't understood.
Let me say it is X.
Oh, okay, sir. I understood now.
Thank you.
Sir, I have another doubt. In Venn diagram, you said like, how can we draw AB bar, sir? How can we draw a Venn diagram for AB bar?
So actually Venn diagram, when you know that, you must be knowing this, what is it, mu.
Yes, sir. Sample. Yes.
Then we need to write everything except AB,
Okay, sir.
right? Right?
Okay, sir.
Right.
Sir, I have another doubt, sir. For
Yes.
yesterday you said, na, sir, like after solving the whole, we have to write the minimum number of gates required for that Boolean expression, right, sir? If we
Yes.
get any one variable like A, then there is no need of any gates, right,
Zero.
sir?
Zero.
Yeah, sir, but for one question, I just solved that, like I messaged you, but you didn't saw as if you were busy, I think so. But in that question, they had answered that they got, by solving that expression, they got one variable, sir. But they answered like it need one gate to like express that Boolean expression.
When did you message me? I will check
Sir,
after that. I'll reply.
today morning, sir, at 11:30, I think so.
Okay. Today morning. Okay. Right. No, question is wrong. Options are wrong. Why do you need?
Yes, sir.
Right? So why do you need logic gate there? D common, ABC plus ABC
Yes,
whole
sir.
bar. It becomes D only. Then why do you need logic gates? So from the given, right, we go with minimum, I
Yes,
think.
sir.
When we don't have answer which you are expecting,
Yes, sir.
which is near to zero, we go with 1.
Okay. Sir,
Right,
I have another doubt, like, okay.
Right. Tell me.
Sir, in topic that is propagation delay, there some questions will be there, na, sir, like we have to find how much propagation delay is being
That we
done in that.
that we discuss in combination circuits.
Okay, sir.
Combination circuit, added circuits, different circuits, multiplexer circuits. Recently, we have been getting questions. Last year also question was there, and similar question was
Yes.
there earlier in 2014. Yeah.
Sir, in previous one boy asked, sir, that his name is Manikanta. He asked like odd number of ones. If we consider odd number of ones, then there will be like he asked one question, na, sir.
Yes.
And how can like how we like thinking like, sir, in this question which I don't know, sir, this slide you gave this question, right, sir?
Yes.
Like we have to find the bits.
ABC,
Yes,
right?
This one. Yes, sir.
Yes, ABC. This one, right?
This one, sir. Yes. Sir, here we have to do trial and error method, right, sir?
No. If you are tracking back also, you can answer, right? Z equals to 1. At inputs of XOR gate, what must be there? Even number of ones. Even number of
Yes,
ones
sir.
means all zeros are 2 ones. And then XOR and XNOR with same inputs, then obviously we get
Yes,
0, 1
sir.
or 1, 0. That means
Sir,
it is not
but,
possible to get all,
yes,
it is
sir.
not possible to get all zeros. The next possibility
Yes,
is
sir.
2 ones. To get 2 ones, C must be 1.
Yes, sir. But in this case, there is no need of like 3 input XNOR gates. Like that, I have a doubt.
Input
Like
XNOR, 3 input XNOR
There
gate
is-
only given in gate exam.
Yes, sir. Yes.
3 input
Yes,
XNOR gate
sir.
only given.
Sir, not like that, sir. Like he asked, no, I have a doubt. Like he given a three input XNOR gate, but we have to verify whether the inputs of the XNOR gate should be even number of ones, like that. Even number of ones,
Even
sir.
number of ones,
Is the yes, sir.
Even number of ones.
Like yes, sir.
Even number of ones only.
Sir, I
Yes.
can't explain. I'm not able to explain.
Yeah, I'll give you clarity tomorrow for all
Okay.
this. I'll talk to Manikanta once. Then I'll take some more examples which I've given recent year also. 2018, I think there was a question. I will discuss. Right? Fine.
Yes, sir.
Any
Okay,
more
sir.
doubts?
No, sir.
Okay.
Thank you, sir.
Thank you. Thank you. Anyone else? Doubts? Yes.
Hello, sir. Good
Yes,
evening, sir.
Farhan. Yes.
Sir, in 25F slide frame,
Going. Okay.
sir, I didn't understand the first question. You have taken directly C there. If we go step by step.
Just now she was asking, right? Same thing.
Mm.
C plus AB C bar.
Sir, not like that. If we consider step by step means.
Then minimized steps will be more.
Okay, sir. I had written that.
If you are having such doubts, after K-map, you can get directly.
Okay, sir.
Once you are getting expression, if you are filling that in K-map, it becomes easy.
Okay, sir.
Simplification, now we are using Boolean algebra.
Yeah.
Then we use K-map, right?
Yes, sir. Yes. Fine, sir.
Thank you.
Thank you, sir.
Rohit.
Hello, sir. Good evening.
Very good evening.
Yes, sir. Sir, propagation delay. The propagation delay occurs due to only system parameter, sir, like capacitor only.
In electronic circuits, RC only, R and C. Do we have effect of inductor in electronic device? Because of small size, inductor effect is 0.
Yes, sir.
Right.
So see, means so that's propagation delay only through a capacitor, not by system get calculation, no, sir.
Delay because of transients. Right?
Okay, sir.
Transient is possible when inductor or capacitor is there.
Okay, sir.
Inductor effect is not there.
Okay, sir.
Right?
Means if 0 to 1 shifting, that was a charging time of capacitor, no, sir.
Yeah, charging time.
Yes, sir. Thank you, sir.
Right. Anyone else? Anyone else? Okay, then. See you tomorrow.